Bistronic is a leading global supplier of system solutions for the sheet metal industry. We provide laser cutting systems, bending systems, automation, software solutions, and comprehensive services.
Sorry, I need a sip. Ah.
He's good, no?
Mommy, mommy, mommy.
Let's say he has a confident voice, yes.
Ma. Shall we? Client happy?
Client happy, but please get to the end of the line this time and add a little verve.
The verve is there. You may not be able to hear it right now, but you will in post-production.
In post, we are in...
We offer worldwide presence and competence. We speak your language and understand your needs. We are here for you.
Sorry, we are here for you. I mean, I hear the words, but I'm not getting anything from them, you know?
Could you please just say the lines?
May I?
Please.
It means that we offer much more than just a machine. We support our customers with flexible financing models, training, maintenance, a long-term spare parts service, phone hotlines and online support. And we also operate local sales and support offices in many, many countries.
Yes. Now you see, now
It's coming alive. We should be saying this.
it is more text, though, so we will have to renegotiate with my agent.
Can't you just record it and we'll look at it later?
Well, I'd love to, but my agent would kill me.
If only. Fine then, continue with the script.
Right you are. Where were we?
At customer service and post-sales services, would you believe?
Rolling.
We don't simply develop machines that cut or bend sheet metal. No, our customers need flexible systems for ever-changing order positions and batch sizes. Automation to achieve top productivity with integrated systems and the right software that cross-links everything. Bistronic stands for Swiss quality.
Sorry.
Really?
Swiss quality. I mean, it's a bit of a cliche, isn't it? And actually, while we're at it, your slogan, best choice, kind of sounds like we've just won the buzzword bingo.
Guys, if you want to sort this out, I'm just going to pop out for a smoke.
Let me explain. First of all, Swiss quality. Do you know the Bi-Star fibre? The Bi-Trans Cross or Bi-Soft? Have you ever seen them laser cutting and bending those sheets? It's like butter. Once you've seen it, you can't help but be excited. The beauty of a laser cut. The precision of a bent metal sheet, from very small to very large, but all with the precision of Swiss clockwork, perfectly formed and expertly fitted. Now, best choice. When you say yes to a partner, be it in business or private life, you make a commitment to the future. Bless you, Katie. Now, you're still young, but one day, you're going to want someone for the long run. Someone who shares your vision for the future. You see, at Bistronic, we think about tomorrow's sheet metal processing. We have some footage of that, right? In what we call the smart factory, variable orders will be produced automatically on flexible systems. A clear vision and state-of-the-art technology means cost and process optimization, which in turn means higher earnings. And who's behind this success? The employees of Bistronic worldwide. Now, you'll say that's just another cliche, but nobody else sets new standards like they do. With their enthusiasm, their ideas, and their know-how. Actually, I stand corrected, because our success is also due to our clients. It's their feedback that we use to develop new technologies. And until they are perfectly functioning, we will not launch them. And none of our employees will settle for less. Not in Asia, not in America, not in Europe, not in Switzerland, nowhere. And that's what we mean by best choice. I'm sorry, I think I interrupted you.
Did you record this?
Sorry, did he say something? I couldn't hear a word.
He says we're done.
Really? That looked like more words to me.
No, really, we're done. But you can stay here till 5, because it's in your contract.
Oh, no, I'm more than happy to do another version. We'll just speak to my agent later on. That's no problem. Gentlemen? Hello?
Welcome from Germany. Good morning, good afternoon. So it's our second event for today, our second international event. Welcome from Germany, from first winter day in Germany. We started today in the morning with -10 and now it's already 4 o'clock in the evening and it's getting already cold again and it's going in the direction of -10 again. But we are inside and that's not our topic for today. Our topic is the first Digital Bending Technology Day. So we hope we can offer you an interesting program. We speak your language. We speak your language, even if I speak English, but we have worldwide our team in many different countries which are speaking your language and they can support you worldwide 24 hours every day. So Bystronic started some years ago just as a laser company, then bending joined. After this, automation came, cutting automation, bending automation, tube cutting. Now we speak already about tube cutting automation. And our core business also, what's getting more and more relevant is software. Software is connecting everything together, not just our devices, not just our cutting and bending devices, also third party and also additional devices like, for example, welding. So software is becoming more and more relevant also for our show today. But we will come to this later. So Bystronic worldwide, we have production hubs now in Americas, we have production hubs in Asia, we have production hubs in Europe, of course. So we produce locally for the world today. We have service worldwide. We have over 30 subsidiaries worldwide. As I told you, we speak your language and our subsidiaries have a lot of service people who can support you with all issues. Bending. Bending is the topic for today. Bending, it's our technology day for bending today. And bending, when we speak about bending, we have, for example, the Express. The Express is our youngest baby in the portfolio. It's the right machine for everybody who is coming, maybe just from cutting, has no idea about bending, and want to enter this business without a big risk and already with good technology partner. And that's what we can offer with our Express machines. We have the Exact Smart for people who just want to know a little bit of Bystronic, who know a little bit about bending already and want to do the next step. And we have our expert range. We are here today in Germany in the Competence Center for bending. And the expert range, it starts from 40 tons and 1 meter bending length, goes over the Expert Pro, which is the right choice for everybody who is looking for highest process efficiency, highest flexibility, and highest accuracy. That's our Expert Pro range. And the Expert Big range, which goes up to 1,000 ton and up to 10 meter bending lengths in standard. We have our solution center. Our solution center is taking care of all kinds of solutions, for example, also for bending, for big machines. So even if you have a customer or if you looking for parts which are really thick and you need to bend them, we have done in the past machines up to 3,500 tons and up to 15 meters. So that's all special projects and we can help you also with these projects. So that's about bending so far. With this I hand over to my colleague, to Benedict. He's the product manager for bending automation.
Thanks, Carsten. Also welcome from my side. As Carsten said, my name is Benedict Kreisel. I'm the product manager for the bending automation portfolio. And as Carsten told us a few seconds ago, bending is a big and long topic for Bystronic, but we see also the trend for our customers to go also for bending into the automation. And for this reason, Bystronic started 5 years ago also to do bending automation systems. We started here with a machine we have still in the portfolio. It's our mobile bending robot, which is the perfect automated solution for our small press brakes. We also went to the Expert Pro for an automation solution. Therefore, we offer now our big bending cell, and for sure, we are also available in the market for tool changing process on standalone press brakes. So this as a short overview about our bending automation portfolio, and also as a short direction what we want to address today in our Digital Technology Day we do for the first time. So some words to our agenda we want to present today. Bending is not possible without cutting. For this reason, we also want to show you cutting software and also our laser, especially our Bystar Fiber, our flagship laser at Bystronic. We also want to show you a system for nitrogen generation for the laser system, which makes the system to an autonomous system regarding the supply of gas. We then want to go in more deeply into our bending software, bending itself for sure, to show you the portfolio and features in our portfolio, which will help you in your daily work. And yeah, in the end, we want to go more in detail regarding our bending automation products. So a day full packed, mainly for bending, but for sure, as I mentioned before, you cannot bend if you do not cut before, and for this reason we also mentioned these two topics today in our Digital Technology Day. This is what will expect you for the next 3 hours, and we are happy to have you here today and present you all these software and also hardware machines and features we have in our portfolio. It's not just a presentation from our side for you. We want to have it interactive. And regarding to this, I will overhand to Carsten, who will show you how we want to do this during our session of today.
Exactly. It's a live event, and we follow also health and safety restrictions. We keep the distance. You will see this in the complete event, that we keep the distance, or we are mostly alone at our stations. We do it online now because of the reasons we all know worldwide, and but it's a great chance to get much more people on board than usually, because usually this was a German event, just our Bending Technology Day, and now it's international. We have many customers seen today in the morning already from Asia, from Malaysia, from Taiwan, from Thailand even, and from other places all around Asia. Now we see Americas more here in the focus, and some from Europe, so welcome. And we are happy that all of you can join us with this. So as Benedict said, we want to make it a little bit interactive so that it's not so boring for you the next 3.5 hours, and we also want to learn more from you. So we prepared this for you. It's called Slido. So if you have a mobile phone or something and you are sitting in front of a laptop, for example, you can read the data matrix code now, like Benedict is doing this. And by doing this, you join Slido, and there you can answer our questions. If you don't have a mobile phone or something mobile, then just enter the Slido page. It's slido.com, and there you find the event entry, and there on this entry point you just type in B555, and with this you enter directly into our event. So the first test question for you is here, and the first question we would like to ask you is what do you prefer to drink? We are at the moment still at work, so at the moment for us it's here the water and the coffee, and let's see what do you prefer. Today in the morning, most people have been preferring beer, I think, and followed by wine, and not so much people have been voted for the water, but let's see if this is now different. We give you a few seconds to enter Slido and to try to vote. We will have this voting system now online over the complete show, and we will ask you from step by step for your feedback. So again, it's slido.com, or just use your mobile phone and use the QR code reader. And with this, you can enter to Slido and go directly to our questions. So now we see here also it's about 17 people. It's about 17 people who have been voting so far, and the majority is going for beer. Again, that's already a great result for us, and let's see how this goes on. Then the first question for us is, or for you is, do you have already any equipment from Bystronic? Do you have a press brake from us? Do you have automation from us, bending automation? You have cutting systems from us. You have a tube cutting system from us. What do you use so far from us? So at the moment, it's pari. It's interesting. Today in the morning, most people have had cutting systems. That's also what we find worldwide. Typically, many people start with cutting from Bystronic and don't know so much about bending. Even that bending joined Bystronic already nearly 20 years ago. So bending is a part of Bystronic since about 20 years, and our bending business goes back many years already, and we have many machines in the market. I already told you at the beginning, we speak your language. We have service technicians worldwide in the market which can support you. We have still machines in the market which are more than 25, 30 years old, and we support them with technicians, of course, and also with spare parts. So we can help you from cutting and bending, of course. And we think we have good know-how. So that's good feedback so far. No? We have 50% of the people have no equipment from Bystronic yet. That's also interesting. No? Okay, it's at the moment just about 20 voters, but it was also today in the morning like this, that many people today in the morning, they didn't have any equipment from Bystronic yet. And this was also interesting for us to see that so many people without Bystronic equipment have been joining this event. So now laser cutting is in front, so it's a little bit like in the morning now, and press brake is following. Yeah, that's getting more and more in the same direction like today in the morning, but we will see. So with this, I hand over to our first part, and everything starts with software, and we would like to show you also this for cutting at the beginning, just very shortly, but at the end you can't bend anything without cutting before. So I hand over to my colleagues Benjamin Bansemar and Louis Palm for this short software presentation. See you in a second.
Welcome to the demo of the BySoft 7 sheet cutting module. My name is Benjamin, and today I will show you how you can import 2D data into BySoft 7, correct them, set the cutting technology, and nest them in an optimized and process reliable manner. We create and import 2D parts with the part editor. File formats such as DXF and DWG can be imported here. Vectorization of image files is also possible. Today we import a DXF. The material, the thickness, and part informations can be specified here. In import mode, you can filter according to different views. I'm using the layer filter for this file. This means that only the required contours can be selected quickly. With the checkered flag, the contour is created and already open contours and double lines are deleted. The part inspection shows you at a glance whether the part is free of defects or whether it still needs to be processed. Bystronic works with the traffic light colors here. Red is not productable, yellow is for a warning, and green for error-free. In my example, an open contour is recognized, which can now be closed independently and quickly. Text and part identifications, such as a data matrix code, can also be programmed as an engraving onto the geometry. This enables quick and reliable parts identification in production. BySoft 7 leads us from left to right to the next step, the cutting process. The data for the cutting process and the nesting settings are specified here. The perfect cutting technology for the existing contours is automatic selected in the cutting tab. Here you have access to assistants which have been created based on years of experience and customer requirements. Lead in, piercing mode, as well as the correct machining sequence and the best operating modes are set automatically. Despite the automatic, you can intervene flexibly and, for example, the operating modes manually set the machining sequence and as well as the lead in and the piercing modes. Nesting plans are created using the part nester module. All cutting machines and material grades can be selected here. Raw materials as well as residual sheets can be added individually. Parts can be selected using a material filter. Only parts of the same material quality are displayed. The number of pieces and other attributes such as mirroring and comment cut can be defined on a part-specific basis. With this information, the automatic nesting can be started. Particular attention is paid to waste the position of the parts, and process reliability. When nesting, the parts are process reliable, optimized and arranged economically on the sheet. The nesting settings can be flexibly adjusted. Any residual sheet are engraved and automatically saved for later use. The processing time, including non-productive times, is calculated for the entire cutting job. With our cost calculator module, the parts cost can also be quickly and precisely determined. With our cost calculator module, the part costs can also be quickly and precisely determined. The cutting and bending data result from the machine parameters. Material and other process costs can also be specified in cost tables. These results can be output in various formats such as PDF, CSV and so on. The cutting job can now be transmitted to the machine. The operator can process the job on the cutting machine without further programming. This is how quickly and easily you can create and calculate cutting jobs with BySoft 7.
Yeah, thank you, Benjamin. Thanks for giving us this short and great overview about the laser software. So how to manage with parts and bring them into the software and bring them then directly on the machine. We all know that software is a big part and a big feature and an important feature for the future for all our machines we build for the laser, for the bending machines, tube machines, and also for the automation. And for this reason, we want to ask you in our next Slido question, what software do you use? So I invite you to also give us your vote regarding the software. Very important also for us to know and also for you. Maybe nice to see what other customers do. So use the software from Bystronic, or do they use another software from maybe a third-party supplier? We try to be as good as we can in software. We'll more focus in the future on software. This is a big goal also from Bystronic, because as I mentioned before, software is a key feature for all our products. And as we can see for the first 9 votes, that most of you use another software. Just 30% use software from Bystronic. Yeah, also our colleagues from the software department, especially the product management from the software department, is part of this technology day. And I think a very interesting feedback also for them, that we have many customers who use another software, or maybe also customers who do not have Bystronic at the moment for sure, they will also use another software. So this will be a little mix here in the feedback from your side. Good to have this overview, also regarding the software. But we have another question for you to vote also for this topic is, if you do not use Bystronic software, and we have seen that many of you do not use Bystronic software, what is the reason for this? So do you not know it's available? Maybe you do not know Bystronic very well and use another supplier for laser bending and tube processing. Or is it the reason that you are not a Bystronic customer? You do not like the performance of the Bystronic software, or is it in the end a price topic that you decided I do not want to go with the software from Bystronic? So some of you have initial experience with the performance of our system and also with the system from a third-party supplier. But very interesting, what I see in all the votes we had today is that we have here in our line many customers which are not Bystronic customers at the moment. And we are also happy to have you here because we can present you today then the whole portfolio for software, bending, laser cutting, and also automation. So we see now that from the 12 votes, the half voted for performance. The main reason is that the performance is the reason why they decided for third party, and the other ones are really not Bystronic customers. And maybe to make you to a Bystronic customer, we want to show you now firstly on our technology day bending the laser cutting system, the flagship of our laser cutting portfolio. It's the Bystar Fiber 10 kilowatt, what you will see in the next few minutes presented by my colleague Eric. And the machine is available in the format 3 meter by 1 meter 50 up to 12 meter by 2 meter 50. You will see today equipped with the feature of a nozzle change. Yeah, at this point I will overhand to my colleague Eric to show you our flagship, the Bystar Fiber laser cutting machine.
So, hello everybody, hello from my side. My name is Eric. I'm application technician for the laser machine and also for the bending machine here in the Competence Center Bending in Gotha in Germany. So welcome from Germany to the world. I've seen a lot of different countries. They are in the chat, they are in the YouTube video. Thank you very much for joining us for the second session of our Digital Technology Day 2020. And for this, we want to start with a really short overview about our laser system, our flagship laser system, the Bystar Fiber. We have this machine now since 3 years here in the demo center. It's a machine from 2017. But we are looking forward to get a really brand new one in January 2021. So we want to talk, but also we want to talk about the main and key features of the Bystar Fiber family. So as Benedict mentioned, we have this machine available in various sizes starting from 3 meter length up to 12 meter length of cutting. This machine, what we can see here in the back, is a 3 meter machine which can cut sheet metals in a depth of 1.5 meter. And also we are good in a wide range of material thicknesses and materials types. So we can start with standard mild steel from 0.8 millimeter up to 30 millimeters of thickness. And we also can cut aluminium, stainless steel, and especially with this machine we can cut copper and also brass material in various sizes. Okay, so this machine is also available in different classes of the laser source. We start with 2 kilowatts of laser power and go up to 15 kilowatts of laser energy we can use for cutting materials. Basically, and important on a fiber type of cutting machines is this little yellow cable we see here. This is the fiber itself, so somebody maybe of you think this is the fiber itself, what we can or what we see, what we have. But basically the fiber is this small cable. Maybe you can't see it quite good on the machine. It's thinner than your hairs, so really thin cable, really thin material, and we can send there really lot of power over this small cable. Some more great key facts about the BiStar fiber family. We have a nozzle changer in the machine, which we can see here. We will see it later on also in motion. We have the detection eye for detecting the sheet really good, really precise. So we don't need to use capacitive looking for the edge or capacitive edge detection. We don't need anymore. We have the detection eye, which is much, much faster than before. It also works really, really good on shiny material like brushed stainless steel or copper. We have automated focus adjustment at the machine side, so we are able to change the focus of the beam using this automated function, so we don't have to change a cutting head or do it manual like you maybe know from older machines. This is fully automatically done by this machine. And also we have a brush for cleaning the nozzle after cutting. Okay, so maybe some words about the control. You see it in the picture also. The control, first of all, looks really clean. We have a lot of buttons. They seen by themselves. They don't have any big deals to do something with it. And what is the main and key view of that picture is at the moment our plan or plan pool, where we can see all the plans we had worked. So they are also at the machine anymore, or at the machine. We have the plans we want to cut, and we have current plans. They are not cutted, but they may be now in the production line. Also, the machine is equipped with a shuttle table we will see later on, where we can easily remove parts and bring in new material. And also a good thing at the machine family of the BiStar fiber laser, same as all other machines of Bystronic, so the bending machines, they are modular. So for you as a customer, we are quite good because you can buy a standalone machine now, using it a couple of years, and then you can decide to have automation in the back. For example, a B-Trans for easily taking raw sheets and unload fully material sheets cutted from the shuttle table. Then you can easily equip a storage system from Bystronic, where you can store your cutted material, or also you can store your raw material in it. We have storage systems from really small up to really big systems using all over the world at our customers. And we are also able to extend this system modular to a fully automated sorting system, which means the machine fully automatic can sort certain parts, special parts for your later work, for example, on the bending cell, or at mobile bending robot, or at manual bending. So you see, we are really open for all your problems, all your things we have around the machine, and we can go and grow with you as a company. So, but let's start. I had talked a lot now about the machine. We will start to cut now. I have prepared a 2mm stainless steel material. We will use these parts later on in the demonstration, so my colleagues will use them later on with our modular tool changer and also with the mobile bending robot. So we don't produce any trash at the moment. We can use everything afterwards again. So for this, we go in the plan pool looking for a job. We cut it already. We cut this one already today in the morning at the first show, first session. Now we want to re-enable it. We want to restart the plan. And for this, we can easily drag them. But now it's the case that you have a residual sheet. You want to work on it. You want to use it because you don't want to throw it away or whatever. We are able, on every time at the machine site, to edit your plans directly on the machine. So you are able to select the sheet size, the blank size, or change the blank size. We are able to set micro joints on it. We are able to set skeleton cuts on it. And we are also able to measure and put another machining sequence on the table. So for this, we will keep the plan as it is. You see the part we want to cut first, and then some parts more later on. but we are able to change everything directly at the machine site. So for this, I restart the plan. So we are good to start. I want to use the shuttle table for easy load and unload the machine, but we are also able to put in the parts directly to the machine site. So shuttle table is now working with the parts. So we bring in the new raw material. With the hand control, we can start the plan, but we are also able to fully automatically run through jobs, run through different jobs all over the night, maybe as a night shift or whatever. So now we do a nozzle control to make sure the nozzle fits perfectly with the pressure. And then we will go to look for the edges using our edge detection function. And then we start to cut the first plan. So machine now cuts out everything. Using the power of a 10 kilowatt laser. So this machine is a 10K laser system. Really fast at 2 millimeter stainless. But as I mentioned, we are also able to bend and cut thicker, really thick material. For sure, we also have different machine types like the B Smart Fiber, which is our flagship machine for you as a startup company. So it's a really good start in the world of sheet metal industry. It's a fast machine and it's not that expensive. But the BiStar Fiber is the golden segment machine since years. So last part will be cutted. Then we do an automatic skeleton cut to take away the table. And if this is finished, automatically the shuttle table will bring out the cutted material. So now we are at the back side of the machine. You see the shuttle table moved out. You see the finished cutted material. You can easily bring them out using them directly for bending this part with our modular tool changer, and the small parts we want to do overnight with the MBR. But for now, I will give you a short look what is currently at the market of Bystronic, what is currently available at these machines. So you are able to have this machine equipped now with 15 kilowatts of power. So you are much faster and you are able to cut also thicker material than 30 millimeters, which is the thickest material we can use on this machine. And we have another really cool functions. The most functions are really, really good for automated production line, but also for minute operation, because it helps you as an operator to make sure that the machine runs smooth and you can quickly go over different problems with the machine. The first thing we have a really brand new cutting head. It's made by ourselves in Switzerland, the cutting head SSC2. It looks a little bit different than the old one. That will prevent collisions with the cutting head. The second really big and nice feature is the NTC, the nozzle control tool, which looks for the perfect centering and perfect cleanest nozzle we have. So if your nozzle is not in the center anymore, the machine will automatically center the nozzle. It's not using by hand anymore. And we have another really good thing, which is curve scan, which means we look through the cutting line, through the cutting gap, and make sure that the cutting gap is cut through 100%, that that we don't have anything down the material, that the cutting head is really good. The next big thing is the beam shaper, which little bit looking for the beam and make sure that we have a really straight, clean cut also at thick material. And the last good thing is for you, we are able to have the option for high power and high speed oxygen cuts, which means we are able in steel material to cut with oxygen the same speed or nearly the same speed than nitrogen at the moment. So these are the main brand new features. We can see them also in the beginning of next year, and maybe with another demonstration or another technology day online, we can show you the new main key features of the ByStar fiber also in the competence center bending. And with this, I want to overhand and want to show you a short video of the ByStar fiber 15 kilowatt to give you some visual pictures of the new and brand new features of the ByStar fiber family. And for this, I say thank you.
Okay. So, what we would like to highlight at this point is also what Eric already mentioned. Live demonstrations are our daily work now, and that's a good thing about Corona again. We do live demonstrations at the moment nearly every day, maybe sometimes 3 times per day or 4 times per day, all around the world, and we can just ask you to join us for an individual demonstration. Today in the morning, for example, one customer was asking if we can cut this 30mm material. Yes, we can do, for example, you can see demonstrations, or you can book your individual demonstration in Switzerland. From beginning of next year, you can book it also here in Germany, but you can book it also in our competence centers or experience centers worldwide. We have, for example, in Korea, we have one in America, United States, we have one big one. We have in China, we have in Scandinavia, so all around the world. We have a new one in the Netherlands, which just opened. So we have all around the world experience centers if you are interested in this. So what you also see here is the feedback so far for our quoting. And now many customers which are here in the group now are not Bystronic customers. And what's also interesting, it's about performance. That's something I can really just say, join us for a demonstration and give us feedback where is the issue with the performance with the software. That's really interesting to find out more about this. Today in the morning there was the issue, the price, more highlighted from many customers. And so you see the differences between different groups also. It's also for us really interesting. So with this we come to the next question. That's about laser cutting, and we would like to know from you what kind of parts you are cutting, what material thickness you are cutting. Is it below 5 millimeters thickness what you usually cut? Is it above 5 millimeters up to 12 millimeters, and or is it even above this? Today in the morning we have it about 30% of the customers already with, which are cutting even material which is thicker than 20 millimeters. That was interesting. And for these customers, we have our big machine series since many years available. These machines, as I told you, it's available up to 1,000 ton in standard range and up to 10 meter bending lengths. You can have these machines also in tandem operation, so you can bend parts up to 20 meter lengths. The longest laser is at the moment, I think, 12 meters we offer. So there is still a lot of room for longer parts, and so we can offer you all the equipment you need to bend after cutting. So that's interesting. Most customers now so far have less than 5 millimeter material thickness. If you are not in Slido, if you lost the link to Slido, it's not a problem. Just take on your mobile phone, type in Slido into your browser, and then you come to the event page, and there you type in B555, and then you are back at the event. Or you can go on your laptop or on your computer and type in Slido, and then you are back on the event. That's interesting here, that most customers are below also 5 millimeter material thickness. And yeah, you see here again, but it's just 10 which are voting, have been voting so far. Today in the morning there was more votings already also. This was also interesting, and it's more statistical evidence afterwards. But anyway, what you see here is what we see very often is also that customers of us, of Bystronic, are between 5 and 12 millimeters usually. But yeah, it's a good feedback so far, interesting. And let's see for the next one, what processing do you do? Is it at the moment just cutting? Is it or is it cutting and bending? Or is it just bending? So what are you doing so far? That's also interesting. What we can see worldwide is many customers coming out of cutting, and they try to get into new businesses. Some customers try to have their own part or their own product, and some customers go into new businesses like bending. We see this also for tube cutting. We have now tube cutting in our product portfolio, and many customers try to move into this direction because it offers just much more business to them. But it's interesting now, many here of you already do cutting and bending. Just a small majority is just cutting and some are just bending. But yeah, I think that's worldwide maybe more or less already typical. So with this, we hand over to our next colleagues. They are from Aircon, and they give us a short presentation about nitrogen.
Welcome to our demo center. I'm Johannes from Airco, and today I will introduce our PSAL nitrogen generator. Due to our expertise and decades of experience, we are able to offer you efficient solutions for nitrogen generation and the installation of compressed air systems. But first, let me show you our PSAL nitrogen generator for laser cutting applications. With our system, you will be able to produce your own nitrogen from your in-house compressed air and become independent from gas deliveries. Our atmosphere contains 78% nitrogen that can be utilized for your laser cutting application. PSAL, or pressure swing absorption for laser cutting, describes the method that is used to produce the nitrogen. In this process, the two absorption containers are filled with compressed air alternately to generate your nitrogen.
After treatment, the compressed air is fed into the nitrogen generator. This operates according to the pressure change process or adsorption process. The compressed air is led alternately into the two adsorption containers. They contain a special activated carbon that's able to bind the oxygen molecules of the compressed air. If one of the adsorption containers is saturated, the system automatically switches to the second container and the saturated container regenerates.
We were able to design this process efficiently to help you to reduce your cost to a minimum. One of the highlights of the PSAL nitrogen generator is the compact design. The entire system is built on a platform. Additionally, everything can be tailored to your specific needs. This compact design makes transport and installation very simple. All components can be moved with a forklift truck. On site, the system is connected to electricity, compressed air, hydrogen, and you are all set for independent nitrogen generation. Of course, we do connect your laser as well. Our system works with all laser manufacturers. Our production is located in Frankfurt, Germany, and all systems are officially approved and certified. Every system is carefully reviewed and tested before it's shipped to our customers. The effort for maintenance is very low. If required, we can offer a compressed air solution as well. You will then be able to supply your nitrogen generator and factory with compressed air from an energy-efficient and modern compressor. If you need advice in the optimization of your energy consumption, we will provide this as well. The nitrogen generation in 2 stages is key for our energy efficiency. In the first stage, we are producing nitrogen with a purity of 3.0. In case you would like to produce nitrogen with a purity of 5.0 in the first stage, more than 3 times the amount of compressed air and energy would be required. We only need 2.9 cubic meters of compressed air for every cubic meter nitrogen that we produce. That is a very little amount, and nobody else can offer this. Nobody else. The nitrogen is generated with a special activated carbon from compressed air. With our unique system, we can reach a purity of up to 6.0 in the second stage. By adding a little amount of hydrogen in our end-cut system, the remaining oxygen molecules are reduced to a minimum. This patented setup makes the compact design and the energy efficiency of our system possible. The generated nitrogen is then buffered in 300 bar bundles. These are space-saving and can be extended at any time. In case your nitrogen consumption increases, you can easily add additional bundles. When your laser is running, the nitrogen from the bundle is then reduced to the required pressure and available instantly. To ensure a clean cut, and most importantly not to damage the sensitive laser head, clean and dry nitrogen is crucial. Dew point and temperature of the compressed air are monitored at the inlet of the system. Various filters and an activated carbon tower ensure clean compressed air. At the end of the process, dryers remove moisture from the nitrogen, so as you can see, a completely secure system. The highly efficient filtration of our system guarantees high quality nitrogen that is available nowhere else. Sensors are monitoring every stage of the nitrogen generation, from the compressed air inlet to the generation in both stages, and then finally at the pressure regulator right before the transition to the laser. In case a variance is detected, the integrated remote monitoring box will notify you via email or text message. A web interface allows you to access all system parameters online. Of course, your photovoltaic system can be integrated into the system as well. That allows you to generate your nitrogen carbon-free by using the energy from your rooftop. Become independent today, reduce your environmental footprint with our PSAL nitrogen generators. Feel free to contact us for more information. Now, thanks for watching. Greetings from Frankfurt.
Good morning, Thomas. Do you want to continue planning the production hall of Brosius Metalworks project?
Good morning, Synergy. Yes. Please start planning.
Start planning. Construction of the Brosius Mud Factory. Attention. Conflicts recognized in planning. Power generation, sustainability, self-contained production of consumables, expansion of production capacity, integration of ideas, impulses employees, material flexibility laser power improvement, automation of production.
Stop! I think I need some help.
Airco is being contacted.
Morning, Thomas. Boy, you scared me. You know the airco button is only for emergencies.
Karsten, I'm planning for my company Brosius the production facility of the future, with improved productivity but sustainable and independent. A smart factory, so to speak. Just look here. I want photovoltaic solar cells on the roof. Then we'll have some real power for the laser cutting with a Bystronic laser. And all completely on site.
Hello, Thomas. Did I hear something about lasers and Bystronic? Morning, Bernd. I knew you'd pop up when lasers are mentioned. Yeah, look here. With this photovoltaic army on the rooftop, why don't we just plan for 2 8-kilowatt Bistar fiber lasers in the new hall? Then you could process an order with double speed.
Photovoltaic army. Awesome. Then you'll have at least 750 kilowatt hours per year. You could easily supply the entire hall's power with that, including the adjacent offices. You would be completely power independent.
Well, talking about independence, what about a fully automated sheet metal high bay warehouse? We could build it right here, behind the laser cutters. Then your tasks will be fully automated, and the material is fed directly to the laser cutters. Our plant manager software controls and in parallel monitors all the processes. That way you can improve the efficiency in all areas.
And who's going to link that properly with our ERP system?
It's already done. Okay, now we've got a decent amount of power and fully automated laser cutters. One more thing is missing for laser cutting. Nitrogen production on site. 'Cause you really need a lot of that when lasering. Yeah, that's right. Now let's make your smart factory really smart. And produce the required nitrogen yourself. And that's real easy using the ambient air. With our Airco PSAL system. We'll scale it to the required dimensions, and then you'll be both independent and sustainable, because the PSAL system only runs on weekends when your laser production is idle. The nitrogen battery lasts a whole week, and the best is the system runs on the solar power from your roof. By the way, we'll use the waste heat from the PSAL's compressors in winter to heat your offices.
Genius. Amazing, Karsten. But the old tinkerer in me sees some potential improvements to your NCAT closet construction. Wait a minute.
You are calling outside our business hours. Please try again later. Sorry, just kidding. Starting process synergy.
Look here, Karsten. It really works.
Great. Now we're definitely your customers too.
Well, for me, the hall's as good as finished.
Not only for you. Look here.
With Airco and Bystronic, you will always have the right partner at your side for sustainable and independent production for a smart factory. Airco, Bystronic, Brosius.
Air, one of the 4 elements and our most precious resource. Even though air is invisible, it surrounds us everywhere, and it's comprised to almost 80% of the element N2, nitrogen. Just imagine you could produce pure nitrogen yourself in an environmentally responsible way and become independent of gas suppliers. This vision is now reality. Welcome to Airco, the leader in independent nitrogen production for laser cutting applications. Our services include planning, production, and of course, comprehensive all-around service. Since 2009, we offer a flexible, sustainable alternative to pressurized gas bottles or delivered liquid gas. The patented plug-and-play system in an all-in-one design, PSAL.
Our PSAL systems, including all components, are assembled here in Frankfurt and mounted on modular platforms.
All components are essentially constructed the same.
The details are then adapted to a client's individual needs.
This laser cut, for example, is only possible with purest nitrogen. These are the small but beautiful details.
These are individually conceived systems which we are continuously developing.
The system is eco-friendly and efficient at the same time. On top of that, it reduces your CO2 output and your operating costs. Airco delivers a patented complete system, thoroughly inspected before delivery and certified. Our plug-and-play system is immediately ready for operation. Thanks to our highest quality standards, maintenance costs are extremely low. And should there ever be any disturbance, we naturally guarantee fast, uncomplicated service worldwide. We at Airco are always there for you, from the 24-hour hotline to the service technician on site and our distribution.
All that is individually customized to suit your needs.
Become part of the Airco family and achieve independence and freedom for your company. Produce your own nitrogen independently and eco-friendly with our PSAL system. 100% made in and assembled in Germany. In operation all over the world. Airco. Discover freedom with PSAL. Nitrogen for real cutting heroes.
Welcome back. Thanks to our partner Airco for this introduction to their product. As we can see in the votes before, most of you use cutting and bending systems, and what Airco showed is a very great and innovative way to increase the autonomy of the cutting system. And for this reason, I want to ask you, what advantage do you see in the in-house production of nitrogen? Is it the independence of the gas suppliers, or, for example, the production according to demand, the photovoltaic system, which can be used for the generation, or is it the reduction of cost you want to achieve with an Airco system if you think about a solution from Airco? So I invite you again to vote here on our Slido. If you do not have Slido opened again, just go on the URL slido.com and enter the code B555. And yeah, you are invited now to also vote for this question regarding our partner for nitrogen supply with their innovative system. So thanks for the first 4 votes. You mentioned that the independence of the gas supplier and the reduction of cost is a big topic. I think these are 2 main reasons from our partner Airco why they developed this product, and this is also one of the reasons why we have Airco as our partner for our laser cutting systems, to increase the independency of our customers, increase the autonomy of the system, and for sure in the end then also reduce the cost because of the unindependency to nitrogen suppliers. Some of you voted also for making space usable, for sure. If you have this system in your hall, you do not need a lot of nitrogen always into your factory. But we can see a nice trend now in the votes that really the independency of the gas supplier is the big plus point to go with a system like this. And I think it's an advantage to have here Airco as a partner for our laser cutting systems. At this point, thanks for your vote to this question. One other question, which is also a topic in general for all our systems, but also Airco is interested to know if the integration of photovoltaics, which is possible with the PSAL nitrogen system, if it's a topic that CO2 savings are an issue for your company. It's a topic which comes more and more also in the discussion in media. CO2 saving is a topic all over the world, also in the car industry. They think also about this. And also we have integrated systems in our bending machines to save in the end energy and in the long term then also CO2. For example, we have in our bending machines an energy saver. This is like a start-stop function in the car, and if you do not use the machine, also our engine runs not, and this is also then a topic for CO2 savings, can bring you then also money if you purchase our machines, because this is maybe then supported from your government if you have machines which are environmental friendly. So we see in the votes, it's definitely a topic for you. I think it's a topic which is an argument for the ecosystem, but this is also a topic in general for all our products, as I mentioned before, also for our bending machines. And bending machines is the right topic now because we are today in the Digital Technology Day for Bending. And yeah, this is the point where we want to switch to all topics regarding bending. We have seen software in the morning regarding our laser cutting system, so how make a cutting plan. But what is also very interesting in the process, how do I do with an offline programming software a bend part? And this is what we want to show you now in the following few minutes to show you how easy the process is to do a bend part in an offline programming for the preparation for the bending process in your factory for your daily work. And at this point, thanks again for your votes for this topic. And now let's go into bending with Benjamin again, who will show our offline programming software for bending parts.
Welcome to our presentation of the BiSoft 7 module Bending. My name is Benjamin, and today I will demonstrate how to import 3D data into BiSoft 7, how to unfold it, and how to create the bending program. We create and import 3D parts with the designer. This module is the CAD module from BiSoft 7, and it is based on the OEM version of SolidWorks. Sheet metal parts can be bendable, constructed and imported. File formats such as SAT and STEP, as well as native part data, can be imported here. Processing of assemblies are also possible. Today we import a step file. With the add-on bending developed by Bystronic, the part can be processed quickly and easily. We transfer the data from the CAD system to the CAM system. The material, the thickness and part information can be specified here. And the bending lines are now visible on the part. BiSoft 7 leads us from left to right to the next step, the bending process. The existing top and bottom tools are loaded from the virtual tool cabinet, and with the automatic bending technology, the part is automatically shortened correctly. BiSoft 7 works with empirically determined values which ensure that the part fits perfectly. The bending sequence, the tool setup plan, as well as the baggage position and further process steps are also created automatically. It is possible to intervene manually at any time and flexibly adapt the process steps. The operator can change tools individually, edit the bending sequence, and define the baggage position. The parts inspection shows you at a glance whether the part is free of defects or whether it still needs to be processed. Bystronic works with the traffic light colors here. Red is for not productable, yellow is a warning sign, and green is for error-free. In my example, a contour is recognized in the entry zone of the bottom tool. This can now be provided with a relief cut independently and quickly. A change to the geometry requires the bending technology to be checked. The bending process is now simulated and the feasibility checked. For the part that is already finished, the bending time is determined theoretically using the machine parameters. The auto part module enables you to process 3D parts and assembly fully automatically and to create bending and cutting programs. In addition to SAT step files, native data, assemblies can also be processed. The assembly is separated correctly, unfolded, and at the same time the flat and bend program is created. Non-sheet metal parts are recognized and filtered out independently. The parts inspection shows at a glance whether manual post-processing is necessary or the component is finished. The components are automatically saved and are ready for production. With the Tool Setup Optimizer module, the bending programs created are now put into the optimal sequence in order to minimize the setup processes on the machines. A bending job with several bend parts is created as a package. The bend parts are loaded and put into the optimal order using the program tools and station plans. Tool time, setup time and bending time are taken into account here. The operator of the machine can thus start the job once and is guided through the shift. This is how quickly and easily you can create perfect bending programs with BySoft 7.
Yes, welcome back. We go on with some questions regarding the bending automation or bending software.
Yes, and we have already our Slido tool activated again. So if you don't have it anymore on your mobile phone, just type in again slido.com and then you can join the event again if you lost this. And we have already the first voters in for the next question. Let's again interesting, that was more or less the same like in the morning, that many people still don't use offline programming software for making the jobs for the bending machines. That's interesting. I'm working now since about 10 years for Bystronic. When I joined Bystronic, there was just BySoft 6, the software we have had in our portfolio, and at this time we already sold a lot of licenses to customers, but when we have been asking afterwards, do you use it? Many said, we are planning to use, but we will see. And now with BySoft 7, that's, I think, changed a lot already, latest since 2015-16, since automation is getting more and more important and relevant. And but it's still like this, that many people make programs on the machine, make the machine ready, and there is a lot of potential also to save a lot of time and at the end money, because when you have offline programming in your factory, you can make the programs for 10 machines, for a cloud of machines offline, and you can save a lot of time because you can make all the programs in the same time. You can export these programs, what you have been doing before on your software, and we have customers that they are sitting, for example, in Germany or in Austria. One is sitting in Austria and makes programs for Slovenia. We have some customers who are in Germany and make programs to bend afterwards in Asia and in America. So this is now a network all around the world, and that is a lot of time saving. And you make sure that you have all around the globe the same products afterwards, if you are in a global operating business. If you are a smaller company, then it's just saving you a lot of time when you make your programs offline. So now, next question is about automation. We are going into automation in a second also, especially for bending, because that's our youngest babies in the portfolio. As Benedict said before, we have this since 2015, 5 years of automation now for Bystronic, and we have far more than 100 small cells in the market. I think it's even far more than 150 already, and that's not so bad, we think. When you see we started from 0 5 years ago, we have now other automation as well. We will go into this deeper. We spent a lot of money for our automation. How much was it, the last numbers about this, how much money we spent for automation software?
It was for the robot manager programming, the offline programming software, of around 4 million euros for development of this software.
So we spent a huge amount of money for the software, and that's also what we see from customers who are using, for example, our small automation. I think we can say they love it because you can save a lot of time. But we will come to this in a second also. And but you see here also, I think the feedback also from you now that this is an interesting topic, this bending automation software. So with this, I come to the next question. You can, don't worry, you can also vote afterwards when we are going on. This questions, it's always for us also interesting, because what we do anyway, we will look at this and challenge these numbers, what we get in this live events. We have, for example, tomorrow 2 more of these events which are live just for the German-speaking region. So with this, I come to the next question. And this is why an easy offline programming is important. That's you are wondering about this question maybe, but for us it's easy to understand, because we launched our first automation software, which was maybe a little bit harder to program, and then we've got a feedback from the customers. We want to go into a batch size of 1, or 1 for automation, maybe not, but 10. We have customers now who have our automation. They make batch sizes of 10. They have different businesses. They are like in agriculture business, they are in forest business, and they have also a sheet metal business, and they make offline all the programs for the machines, and then they can do the other business. Some others can join the hobby or can go into restaurant if you are able to. Like in Australia, they are corona free since yesterday morning, as far as we know. So this is possible again, and in some other places as well. And so you can use your time. And here we see programming time is important. Yes, that's also an important point for our software. That's what you see. We can just highlight this again. Join our live demonstrations. You can ask your local sales manager for this, and we can book a live demonstration here locally, for example, or worldwide in our experience centers locally, and then we can do a live demonstration of your parts, because with our parts it will work always, don't worry, but it's more interesting to have a demonstration with your parts. So you are really welcome to send your parts to us. We will prepare a demonstration for you, and you can see this then with us here in your individual demonstration. As I said before, we do this now as a daily business, this individual demonstrations, and there you can see that with the latest version of our Robot Manager, or the new version of our Robot Manager, which is fully integrated into BySoft 7, you are from programming time really fast, and it's easy to use. And there we see it's two important topics and small batch sizes, but it's also relevant for some of our customers. No? So it's thank you for this feedback, and with this we come to the next question. That's also interesting, especially when you think about automation, because I think, or we think, you don't want to make your program step by step or part by part. That's something you have seen for many years now, maybe, that you import one part and then you make it ready for your laser, and then afterwards you make it ready for the bending machines, and you're wondering why this is so interesting, and that's really not this century anymore. And because of this reason, it's interesting for us. How often do you do this already? How often do you import a group of parts? And how often you use this feature? We have for this, for example, in BySoft 7. It's called AutoPart. You can import a group of parts. If you have your own product, you can put in your complete product. And then it's searching automatically for the cutting sequence, for the bending sequence, and then you can take this over into your automation, and with this you can save a lot of time. As a job shopper, it's more or less the same. You can more or less basically put this system in combination with an online quoting system, and then you get a group of parts in, and then you get all the programs ready. And we come to this later on. We have Plant Manager ready. You can take these jobs into your cutting job list, into your bending job list, into your automation job list. You see when which part is cutted, bended, everything you can see in our cockpit solutions. You can see this in real time online, and so that's interesting. But now for now that you do it seldom, so again I can just invite you for a demonstration. Yeah, send us your parts, and we can give you a demonstration how you can import them, and we make them ready for cutting, bending, and bending automation. And you can see there are also some other features in our software, like tool setup optimizer. That's something what Benjamin was highlighting already in his presentation. Even without an automatic tool changer, you can save tool setup time with this tool setup optimizer, because this tool is looking for the right job sequence. So with this, we go over to the next topic, and the most important topic for today, because it's a digital technology day for bending, and now we really start to bend. I hand over to Stefan, who is now on our Expert Pro, latest generation of our machines, and he will give you a short overview about the Expert Pro.
Thank you, Carsten. I'm here in front of our Expert Pro Dynamic Edition. It's a 150-ton, 3.1 meter bending length. It's equipped with a 6-axis baggage. We're going to see in a second how it's moving. It's a Dynamic Edition. That means it's the quickest press brake that in our portfolio. So it's increased high speed. It's increased bending speed if needed. So we can. We have an increased output of parts. This machine is equipped with a lot of automated compensation systems. One of them can be LAMS, Laser Angle Measurement System. How this is working, I show you in a second. We have our touchscreen here. Our control shows us how to put the part into the machine. We have a 6-axis back edge. With this, we can use the snapping function. So we have one contact here, one on the side. Therefore, the part is always on spot, always on point where it needs to be. I will open the compensation page so we can see what our laser angle measurement system is doing. Target is to bend 90 degrees. First cycle, we're going to bend with database. That means the LAMS is measuring to 90 degrees, and the spring back is set in the database. The third bend will be with active spring back measurement. That means we can see especially the disc here on this side, we can slide them together a little bit apart. That is when we measure the spring back, and then it will overbend the spring back. So you can see the disc going in, going a bit out, and going in again. And we can check the result. It was 89.9 degrees. We have actively measured a spring back of 1.8 degrees, and in the database we have a spring back of 1.9 degrees. So there you can see a little difference. What does it tell us? So whatever grain direction you use, whatever, maybe you have material quality deviations from one sheet to the next one, therefore you have a different spring back, therefore you have different actions what the material is doing actually, so you will always have a different angle. Now, of course, you can do it, measure manually by hand, make corrections and so on. With this system, you are on time and having absolute perfect results. So it's a really, really big helper and time saver if you have a not stable quality of material. So I'm going to change to another program. We're going to program this live on the machine. Press new. I set the material is going to be by steel. Thickness is going to be 5 millimeters and bending length is 1000 millimeters. Top tool is going to be P7 RFA and a V32 30 degrees. What does it mean? This is how the tools look like. We have a straight punch with a radius 3 on the bottom, and we have a 32 millimeter wide bottom die with an inlet radius of 4. Now, I'm going to close the properties, and now I have a blank page where I start to draw my 2D part. I can go in 5 millimeter steps and also in these angle steps. Whenever I'm in between 5 millimeter steps and of course in between the angles, I can set them manually to what I need. For example, I'm doing a drawing like this. All of them should be 50 millimeters and 90 degrees. So I didn't hit the correct spot, so I can change the length and I can change, of course, the angle as well. So now I can click on every of them and do it manually, or I open the table, and here I have an overview where I can also set quickly all the correct numbers. Directly here on the machine means if you not have the time, or if you not have the software, the offline software, so you also can use this, of course, to program directly on the machine. So I close the table, I open the properties. On the section, I can see the plank size going to be 255.23 millimeters. Now I'm exporting it from Profile Editor to the BioVision Bending, our bending program. No, I do not want to save it. Now I can see it's already a 3D file or a 3D part, so the 2D is stretched by the 1000 millimeters. Now we can see here, can be produced is red. That means the technology has not been calculated or not fully calculated yet. Therefore, I go to Technology and click on Automatic Calculation. Now it's calculating bending sequence, tool setup, what points of back edges we're going to use, if we're going to use our bending aid, lumps, and so on. So here I'm now double checking the bending sequence because I would like to have a certain bending sequence. If I often have a different idea of how to bend a part, I can change the parameters here in the machine, how the machine is calculating the part or the bending sequence. And even if the machine always calculates correctly, I still can make changes. So first bend is okay, second bend is okay, third one I like to rotate. Fourth bend, okay, fifth bend, okay. So now bending sequence is done or is changed. Therefore, of course, the back edge positions have changed and the software is recalculating everything just by one click. So I'm going to remove the tools or change the tool setup. Here I'm now using it manually. So I insert the V32, 2 pieces, each 515 millimeters long, to be a little over a meter. I'm also changing the top punch to shorter ones. It's with our RFA system. I just hook them in, and when I close the tool clamping, it's automatically pushing the punches upwards to their reference or contact point. Now, here's my part. We are going to bend. We programmed 5 bends, all of them full material, but we do have cutouts. We're not going to tell the machine that we do have the cutouts. This machine, with its automatic compensation systems, can see or can detect that it is using less force, and therefore we're getting less pressure and less compensation where needed. So I'm starting with a small piece. It's just 5 centimeters. This is my reference piece, so I can double check all the angles of the other part. So this is going to be my reference. I place it right here. Just jump one step back, and now I'm bending the full part. I'm starting with the big cutouts, so we can see an increase of pressure on our crowning system. So, first bend, long cutouts. Second bend, a little shorter cutouts, therefore more material. And, oh, excuse me, even more material. And now we finally have full material. So I will place the part right on top of here. Here is my reference piece. So the machine has calculated a tonnage to bend this part of, you can see here, pressing force 53.5 tons. For 5 millimeter, 1 meter bending length. We now bend 5 centimeters instead of 1 meter, and we also bend the full material. We can see absolute no difference. That means the machine is automatically compensating and detecting that it needs less force to bend the part, and therefore is adopting all compensation. What compensations do we have? We do have pressing force. The first bend with the long cutouts, we had altogether a little bit over 5 tons. On the last bend, we had a little over 30 tons. No, a little less than 30 tons, excuse me. So the machine is detecting, okay, I need less pressure to bend the part to reach my bottom target position, and therefore is adapting all the other values as well. Not only the crowning. The crowning is here on the bottom, are 3 cylinders installed to keep the center leveled. That's the crowning pressure right here. On the last band, we had a little over 60 bars here on the bottom, and on the first band, we had 25 bars on the same spot. Just because we do have less material to bend, therefore we have less deforming on the bottom, therefore we need less pressure to keep it straight. It was also compensating the frame deflection. I will move the beam up. So here in the back is like a C designed, the side frames of the machine. And when you put pressure on them, of course, they open up a bit. On the first band, it was 0.1 millimeter on each side. On the last band, it was 0.3 millimeter on each side. So the machine is automatically compensating that without the operator need to jump in and need to make changes for the pressure and so on. Also, we do have temperature compensation. So compared to this morning, we had a frame growing of 0.03 millimeters because of a temperature raise of about 5 degrees. All right, so we have seen our 6-axis back gauge with our snapping function. In case we have a 4-axis back gauge where we cannot use the snapping function because the back gauge cannot move separately into different positions, there we can use, if we need, for example, we want to bend a funnel, we can use bend line laser. It's projecting a green bending line. It's adjustable. I can just remove it from this side, put it on the other side, and also to other machines. So it's very handy, very helpful. The other green light you can see here right on the tip of the tools, this is the hand protection, the finger protection. So in case something is in the way, the beam will stop right on time, right on spot, will stop safely. This system is our Fast Bend Plus. It's moving automatically to the programmed height of the top tools. I want to show you something. Protective device. Tool change. That is the tip of the tools. So if I move my finger here right on top of the tip, we can see that. So we teach the system the shape of the tools, and therefore we have the possibility to go in high speed right on top of the bend part. This saves a lot of time on every bend that you do. So that was from my side. Thanks for watching. I hand back to Carsten and Benedict.
Okay, so we've got the next questions from you, and Gerrit was helping already to answer them, and we also would like to give you a short feedback about a question about a bending sequence, for example, if the software is determining this the best way automatically. Of course it's doing this, but you can choose what are you looking for, and you can choose on the machine, and you can choose also offline in BySoft 7 what is the preferred way how the machine should choose for the right bending sequence. And that's something which is open for every operator individually, and even if the guy which is doing offline the programming has something different in mind than the operator, it's possible that the operator can adjust this. If he has the allowance on the control, because on the control you have different operator levels, of course, and you can say, okay, this is a master operator, this guy should be able to adjust something, and the other one even not. And so that's what we try. We try to have our systems as flexible and open as possible. And with this, I give over to Benedict for the next question.
Yeah, thank you. Another question received us during the presentations we had before. So the question was if we use the plant manager in our own production in Switzerland. Yes, we do. And also here in Germany in our production for the press brakes and also the press brake with automation, we also use the plant manager to control this. And this is also a little hint to you. So if you have questions to us, please feel free to ask your questions into the chat. We will go and answer these questions also here live for you. So if you have questions, it's an interactive way we want to do it today. So please feel free to ask these questions. And in between the presentation from Stefan on the Expert Pro about the features, we already started our 12th Slido question. And the question is about what you were most interested about the presentation from Stefan regarding the Expert Pro and the features. And we see here also a trend that the performance of the machine is a big topic for you, and you are very interested in it. Also the laser angle measuring system, which is our measuring and correction system regarding the bend angle. Also the dynamic crowning was interesting for you, and less in the focus was the Fastbend Plus. In your opinion, this is our safety system, which is automatical adjustable to the height of the tools you set into the clamping. And the bending line laser was also not in the focus as the also as the RFA clamping for a fast tool setup. And we see performance of the machine was a big topic. You as bending product manager, Carsten, we have 3 different types of machine performance in the Expert Pro. Maybe you can tell us a little bit more what's the difference between classic, performance and dynamic of the bending machines.
Yeah, we try to follow different needs of the customers. Every customer is a little bit different at the end of the day and has different needs for his equipment, and that's the reason we have there, for example, flexibility. We have a classic edition and performance and a dynamic edition, and basically the difference between classic edition from performance and speed, what we speak about is the approach speed. This means how fast is going is the upper beam coming down, and the bending speed, this is then the working speed. How fast do you bend? And that's nearly double. So this means when you have a classic edition machine, you bend with half the speed compared with a dynamic edition machine. And that's interesting also for automation. We come in a second to automation customers as well, because especially there you have a lot of movements also of the upper beam, because the automation needs to take the parts out and so on. And it's much easier and faster to program these parts when you have more space for this. And there you have the dynamic edition. There you can see how you save also time with the performance and the speed of the machine. But also in daily use, we will come to this later again, to our small machine, the Expert 40 and the Expert 80. They have been launched in the past because of speed, fast bending of small parts and medium-sized parts. But there are more and more customers who are asking for more performance and speed, even for bigger parts. One customer was asking about handling time, rotation time, and so on. And then at the end, you want to bend your parts fast as well. And that's the reason we have different options to follow different needs: classic, performance, and dynamic edition.
Okay, thank you, Carsten, for giving us here detailed information regarding the performance of our Expert Pro series. We want to go on with a short quiz. This quiz question, so feel free to enter now our quiz. This quiz question is also about a feature on our Expert Pro, which is unique for Bystronic. Sarah, we see now Sarah already joined. Thomas already joined here for the quiz. And we want to ask you a question, and we will also have then a winner in the end for the quiz, who will give, where we will see who gave the correct answer and who gave the most fastest answer. This feature, which is addressed in this quiz question, as I said, is unique for Bystronic, and this feature will help to have the constant bending angle over the whole bending length during the bending process. This is a feature which helps in bending parts stand alone on a press brake, but for sure Also automation, bending automation is a big topic, and also in this process it's a big benefit because if you can guarantee the correct bending angle over the whole bending length in a process, especially in an automated process, you guarantee good parts in the end of the process. So we see that people from all over the world joined here for this quiz. And I will switch now to the question, and then we start with the quiz. What is the correct answer? And if you want to win the race and win the quiz, be quick with setting the right answer to the question. So the question is, how do we guarantee constant bending accuracy over the complete bending length? Is it done with the optical tool detection system? Is it done with the laser angle measuring system? Is it done with the bending line laser? Is it done with the dynamic crowning Stefan talked about? Is it done with the Fast Bend Plus? Or do we guarantee a angle accuracy over the whole bending length with a fast tool setup with our hydraulic RFA clamping? So you have around 55 seconds left to answer this question. We will see how concentrated you listened to Stefan's presentation. Stefan mentioned this in his presentation on the Expert Pro, and then we will have a winner in the next 35 seconds who marked the right answer and also who were the fastest in answering these questions.
So maybe in the time in between, we can use the time to answer one more question. We have here, this is about Plant Manager. We use the software on many of your machines, and this is a problem since it does not always work properly. I agree with you that this is really a problem if this is the case, and this shouldn't be the case, and that's something, then we need to correct this. And you should get in contact so we can keep your details. Just send a direct email to me, for example. My name is Carsten Trautwetter. I'm the product manager for bending, or send an email to our sales person and they forward this. That's a good feedback also for our product manager for software. His name is Vlad or Vladimir. And Kanzu, they are both product managers for this, and they are hunting this kind of stuff, and they try to solve this kind of issues if they know that there's something wrong outside worldwide, and I will forward this information to them. So we will come later in this Slido questions again back to this topic as well about Plant Manager, and you can type in there also what's exactly the issue in more details, or you go directly to us over the sales manager or direct way to me. You just need to add to carsten.trautvetter at bestronic.com, and then you get an email direct to me, and I forward this to the right person, and we try to solve this issue for you as fast as possible. So,
okay.
Sorry.
So let's go on with the quiz. We said we will have a winner. First of all, we see that most of you voted for the dynamic crowning, and some of you voted for the laser angle measuring system. And we see that the right answer is the dynamic crowning. Dynamic crowning guarantees the bending accuracy over the complete bending length, and the laser angle measuring system guarantee that we have exactly the right angle. So we measure the angle, we correct the angle, but to guarantee to have this over the all bending length, this is done with the dynamic crowning. And this is the right answer. Most of you listened, interested, and we will show now the winner. And the winner is Sebastian. I don't know where Sebastian, from which kind of country he joined. Maybe he can write it in the chat. Then we also see where he came from. And he answered in 9 seconds, closely followed by Stefano, Terry, Albert, and also Eric, which voted for the right answer and were close to win also this race. So thanks for joining also this little quiz. It's not just about the quiz, also to give you the information what dynamic grounding is doing. And as I said, a unique feature at our Bystronic press brakes. What we talked about before is a lot of bending automation, but we haven't seen bending automation till now. But this is Technology Day bending, and for sure we will also show you then bending automation. On the one side, software, on the other side, the machine live running. But we discussed this also before regarding the software questions, that software is a key feature for bending automation because the batch sizes get smaller. You do not want to lose time in programming parts for our bending automation products. And for this reason, we want to show you now the unique robot manager programming for our bending automation systems, especially the mobile bending cell is shown here for the robot manager programming. And at this point, I'm happy to overhand now to my colleague Garrett Gerritsen. Some of you may know him very well, and I'm happy that he shows us the robot manager programming today. So it's your turn, Garrett. Let's show our customers what we can do with our robot manager programming.
Morning. I'll show you how to program a part on our new robot manager. This is a software we developed to program our robot cells, and it's extremely easy. Right here you see the main page. I can open parts, that's what I'm going to do. These are the parts I used last. These are already projects which exist. And here I have my customer database where I can find parts which I want to robotize. So I take this one here. Here I choose my cell. I know that I have this cell, choose that one. And now we get to the main page of the robot program. And here we have to choose, for example, the cell, the grippers and everything. I can check my part again, double check it. All right, this is the cell. So I see my pickup pellets here, I see my chute, I see the machine. I can switch different things on and off. Yeah, normally I want it like this. This is the easiest to program. So what I need to do here is to choose a gripper or a vacuum cup. That's what I did, and then I make a program. So that's what it does here. I can verify all this. I don't want to do the dual sheet detection. I know that my parts don't stick, so I'm fine. Create a program, and it will now make blocks. For this program, I need 2 blocks for the bending. They're right here at the bottom, and then home position, pickup, that's where I am now, reference, and drop it in the chute. So this is where we are, and this first bit is about the part itself. So I need to tell the machine where the part is. So I say, yeah, it's here, it's fine. Next position. What we've tried is to use as least possible this side here where the numbers are. I don't want to type numbers. I hate numbers. So here, this is the reference table. Parts should drop in this corner. So what I do is I let it drop. We calculate. We have a physics engine in here. Friction, gravity, inclination, and it drops right here in the corner. So we're good. Last bit here is how am I going to let it drop in the chute here. Chute like this. Maybe put it in a little bit more. A little bit more. There, that will drop, no problem. And once I've done that, I'm finished here. There's no more black arrows. So next one is the gripper positions. I need to do the same thing again. And what we've done here, something very clever. I have a before and after view. So if I make a movement here, I can see the result of that movement here. So if I make this movement too big, then it results in a crash here. I don't want that, so put it back. Normally what we calculate is pretty good. You don't need to touch it. So next position, from here to here, that's fine. And then first bend, second bend, and then drop it. Again, if I want to move something, I can move it, no problem at all. Put it back. And again, also here, of course, if I touch something, it will get red, and that's basically a bad idea. I leave it like this, so that's basically it. At the bottom, everything is yellow. That means that I've done it, and now I need to create the robot program. So first I hit this optimize configuration. Now the software tries to eliminate unnecessary movement. It's done that already, and then check. Now it's connecting all these blocks together, and if there's a collision between blocks, like I have here, it's red. This is red, there's a collision. Also these little dots indicate the collision, so if I go there, then I can actually see the collision. It will go through this thing here. That is not a good thing. But we've noticed that there is this collision, so we've already done the next step. We've created these two blocks in between the other blocks. So here, these two red blocks are points in space, which have not been calculated yet. But if I push this button, it's calculating. So we add points in space, and now I have a complete collision-free robot program. So this is it. This is done. What I can do now to make more autonomy in the cell, for example, I can make a stack pattern. Here I can say copy this one in the Y direction. So I've got two now. I can enter my pins. I want a pin here. I want a pin here. This is for the operator, to shift his parts against. One here, and I see that this one is red now, so I need to move it a little bit more like this. That's okay. And then I can do the same thing for the place position. That's here. Again, I can just say copy this one, copy it once more, like that. Yeah, fine. So I don't get a big pile in the end of my pallet. I get a nice 3 little piles. That's much better. I need to calculate these parts because I've added positions. So I hit check again. So it will recalculate everything. The middle bit, it will stay the same because I didn't change that. And now I have new positions. Everything's green. The pickup positions are here, and these are the shoot positions. And everything is done now. I can run this. I can choose here which one I want to see. This is the first one. Reference position here. It's the middle one. So let's simulate this. We choose the views automatically, so the operator can see exactly where the movements are. This is happening 100% in real time in the cell also. You can block the view with these little buttons here. So now our program will keep this view until the end of the simulation. I will unblock it because otherwise we can't see where it drops the part. So bend number 1, bend number 2. So I wasn't talking, then making a program like this will take 2 minutes, 3 minutes maximum. Of course, if it gets a little bit more complex, I'll need a little bit more time, but it's still super easy to make programs with Robot Manager. I'll unblock this again, and then it will put it on the output here, and then it will go back to the home position. So that's it. I need to save this part. I need to export it to the machines. That's what I do here. Save, and then here, and it will also make a drawing with where the operator has to put these pins, the pins for the table, so he can put them in the right position. And that's it. I'm all done now. Another little feature in our Robot Manager. Of course, when you do some automated production, you need stacks to pick your parts up, and it would be nice if you could have stacks also to lay your parts down. And that's what I'm going to show you here on the Robot Manager. So I've done the part. It's the same as before. I've changed the cell. So now I've got an 80-ton, 1.50 meters, and I've got this conveyor to show you better what I'm going to do. So this is all green like before. And then we have to go to the stack pattern. Stack pattern, here I see my pickup place. And the easiest thing to do would just go here and say copy, duplicate, and then it made another stack. That's easy, make one more. There, I've got 3 stacks already. And then I can also duplicate everything here to another pallet. This is the other pallet, duplicate here. So now I've got already 6 stacks, so this can run for hours and hours. I'm going to take them away again and show you some more details. Here, pallet 41, that's this one here. Also this one here. Let's leave these 2 stacks because it's not done with only the stacks. I need to put these pins in. I need to reference the parts. So I'll put a pin in here and I'll put a pin in here. So this is fine. You can push your part against this pin and then it's referenced. And the same thing, I'll put a pin here. Ah, it's there already. And one here. So if I would duplicate the stack now, it also duplicates the pins, of course. What's happening, we're checking collision with these pins. Of course, first of all, the parts against the pins, but also the robot against the pins. If you put everything full of pins here, the robot cannot get to the last sheets on this stack anymore. Also, we simulate and we make the program in the way you've put the stacks down. So this is the first one, second one, third one. You cannot start here in this corner because everything would be full with parts. It doesn't work. So this is okay. Then again, you can still see that there is a little bit of space here. That doesn't really matter, you know. The moment you touch the pins, it gets red, but it doesn't need to be that precise. If you're within, let's say, 5 millimeters here, that's good enough, you know. You don't need to make really precise, super neat stacks. They're going in the reference table anyway, so you're good. We also have customers who just put this stack against this one, so they save pins and of course they save space also. So this is the pickup stack, and then we go to this stack here, the place stack. One part already, and again here I'm just going to copy it. There I've got a second one, and then I'm going to put a third one on top of it. And since we don't have an automatic function for that, I need to move the part up a bit, move it over, and then maybe maybe twist it a bit like that. And this is my output stack. So very easy to do that, no problem at all. And then what I still need to do is, of course, make the program for all these things, because I've actually made now 2 different programs here and 3 different programs here. So I go back to parts. Here we see it's like a little railroad. So this is the original one, and these are the ones I added. Also here I see the other references, and here I see 3 place stacks. So I run check again. It's going to simulate everything again. Once this is green, maybe it's not all green, maybe I need to change 1 or 2 positions. It's all green, great. So if I want to see that last, this one here, the second stack, yeah, and then I can simulate it, and you will see here at the beginning that we will pick up from here. So it's already made the program. I'm just showing you the simulation. So running through, referencing, and it's going to do the 2 bends. So I've actually made now 5 little different programs. You can use up to 4 different parts in our cell, the little cell. So you can have 4 different parts on these 2 pellets, and the moment your tools are okay, you can swap between parts automatically. We make a job list, and you can swap from one job to the other automatically. So you can have like 8 hours run in that cell, no problem at all. It is already the last bend, and then it's going to put the part on the conveyor there where I put it. This is the second place, and there we are. Program done, everything done. We're good to go. Thank you.
For all our bending automation products in the portfolio, to have such a strong robot manager programming, which makes it very easy and intuitive to program all our bending automation systems we have in the portfolio. And in the next few seconds, we will show you directly the machine Garrett programmed in the robot manager programming. So we will directly see this machine live here. Also, we will have a presentation about this automation system. It's the Expert 80 with the mobile bending robot and the conveyor belt attached. So fully automated bending system for smaller parts you will see in the following. But before we go to the machine, we just want to ask you 2 more questions to have the interaction with you again, to have your view about bending automation. And we want to ask you if bending automation is interesting for you. So is this a topic you think about? We have seen in the questions before you do cutting and you do also bending. but is it already in your focus to have also bending automation in the future? And yeah, why is it interesting for you especially? Is it the less uncertainty of the production output? Is it the part quality you want to increase with a bending automation system? Or is it in the end just the cost savings you want to do with an automated system? Or do you do not have an interest or any interest into bending automation? And yeah, already 5 of you, 7 voted, and it goes also in the direction as we had the feedback in the morning session, and that really the constant part quality is really yeah, the reason why you are interested in bending automation. So you will have deviations maybe in your manual bending operation process, and you think you can increase this with our bending automation systems. And that we can really address this point, and that we can do this, we can show you in a few seconds live here on the machine. We can show you then also the parts, that the quality and accuracy of the parts is really constant after the process. But before we switch down into our experience center to my colleague, we want to add another question regarding the bending automation. And this question addresses yeah, the purchasing criteria, what you have in mind when you think about bending automation. Is it mainly the price topic? Is it the speed and performance topic you want to improve or achieve with a bending automation system? Or is it in the process, in your daily process, the reliability you want to increase with a bending automation system? Or the constant part quality, so do not produce parts which are not correct, so just produce parts from the beginning which are correct, and this all over the whole bending process? Or is it, in your opinion, the application flexibility what you want to address with a bending automation system? And we see also here that we have a clear view, also similar to the feedback we had in the morning, that speed and performance is a topic, and I think this addresses then also yeah, the cost savings you want to achieve when you purchase and bending automation systems, that you have more speed in your process, and also again, the constant part quality is a big topic. So be faster and be more accurate. Yeah, could be the summary of this vote from your side, why you think really about bending automation. I will keep this vote open for the next few minutes, but enough from my side. We want to see the bending automation system we have seen in the offline programming live. And for this reason, I overhand now at this point to my colleague Eric, who will show you the Expert 80 with the mobile bending robot and the conveyor belt.
So then, hello again from my side. We are now in front of our mobile bending robot, which is attached to our Expert 80, which is one of the smallest machines we have in the portfolio of Bystronic Bending. We have one machine which is smaller. This is an Expert 40, so we have 40 tons by 1 meter. Really small, fast machine for perfect small batch parts and batch sizes in minute operation. But we are able to attach this machine also to our mobile bending robot to give you a mobile solution for automated bending. And also, as I tell you before, we had the modular way, so we can easily attach also a part slide on this machine to make sure that your parts can run out really good, really smooth, with no scratches on it, and with ergonomic unloading the parts from the conveyor belt. But this machine is also available with a part slide, so then you can put it in a box, in a wooden box, or whatever the parts fall in. But this is the most ergonomic and efficient way. But these were the first overview things in the machine. Now we will go inside to make sure that you see all the components of the cell in motion and also in real. So for this, I opened the front door. We have 3 doors attached to the machine. We have one in the front, and two in the side to easily get access to the mobile bending robot. The front side is for load parts inside of the machine. For this we have two pickup pallets, steel pallets with that little pins in here. So you can attach your parts really easy, really simple, really fast to this pallet. We have two of them to make sure that we can have various jobs on the pallet. So we have one job here and we have two jobs on the other pallet, but we are also able to have more than two jobs on each pallet, so that you can run through the longest possible time during your robot operation. The next smart thing on this mobile bending robot is that little pallet. It includes the two pickup pallets, the two tilted pickup pallets. This one is a connection of both, and this pallet is able to remove with a forklift. And if you have a second one, you have a really quick interchange between various jobs, so you can put out the new one or put in the new one, which comes from the laser to unsort, and then we put it in here, change really quick, easily the jobs and also the raw material pallets. So then we go to the right hand side of the mobile bending robot, starting with our double sheet detection. This one is for detecting more than one part which maybe sticks together. Because there is oil on steel parts, most of the thin steel like DC01 is oiled, so you have a little oil surface on it, and then you know it maybe that the parts or the raw parts will stick together. And for this we have the double sheet detection to make sure that we don't destroy the tools, don't destroy the machine, and also don't destroy the robot. Next to this we have attached our alignment station. The alignment station is for align the parts before the bending process will start, which means that we have a really good aligned part, really precise part to go through the bending sequence, really precise to make your part as best as possible. Then we have on top here, we see our regrip station. The regrip station is equipped with 4 suction cups in various sizes. They are movable by hand, so you can move them really easily from one side to the other. And we have one clamp gripper, which is attached for your parts when you want to clamp them. Then we have the biggest and most important thing on that cell. It's the little robot. It's a KUKA KR10 robot, so you can handle up to 10 kilograms, including the gripper, which means that you can handle parts up to 7 kilograms when the gripper is then round about 3 kilograms. The gripper change itself, it's really simple. I go inside now to show you how easy it is to change the gripper. It's just a little pull on this knob. Then you can unlock the gripper, take the next one, attach them to the front, and lock them to the robot arm. So then we have some more things in the machine. They are also really important for the managed operation. We have a really ergonomic table in here to make sure that you can work in sitting position, really ergonomic, so you can store your parts, your raw parts or finished parts on that table. It's high adjustable perfectly to the position of the lower tools. Then we have a 6-axis baggage system at the machine side to make sure that we can easily attach and find all positions at your part. And special for the robot, these 2 fingers or 2 back edges are equipped with contact fingers. So when the contact finger gets pushed, the robot knows, okay, he is in position to start the bending. And this means that we are really precise at the correct position for the robot. And then we see again, as Stefan mentioned before, the optical bend guiding system for give you a really good quick overview as operator where your tools has to be in the position, where you have your station, at what station you are at the moment, where you can find your back edges, and how is your pressing force. And also the optical bend guiding system can show you the cycle counter, the current cycle counter Okay, but this machine is equipped with one more cool feature, especially, or not especially, but good when you have a robot, and also good when you work in manned operation. The machine has an optical tool detection. Sorry, it's a camera-based system which detects these little data matrix codes which are engraved to the tools. And with this data matrix code, the optical tool detection will show you the correct position of the tools. It will show you if you have put in the correct tool type and if the rotation is correct. So we're good to show it. So I go to the control again, to the tool setup plan. And there we have this little camera system, little camera based. And maybe you see not the best, but you see the upper tool is green. You see the position fits perfectly, the length and also the rotation right. The lower tool he can't detect. He just show you that the tool is on point, because at this tool there is no data matrix code attached, which means that we are not see the tool at the moment. And for this, we can close the doors now and go in robot operation mode. So just close all the doors around, make sure that this knob is turned correctly, and then lock the doors using the door lock switch. And now we go back in our BiVision robot. So the robot is also controlled using our controller from the machine. And now you see we have one job in the list which gets a red warning. So you see we have to do our checklist in the edit mode. And so we can start to go into the edit mode to put the 5 tick boxes in that says, okay, I have the correct tools, I have the correct gripper, I have set my regrip station, I have set the target counter, and also the bend part was set it up. You are also able later on to make sure that the robot is in the correct position. When you put in a new part, then you are able to correct really easy and simple the positions of the robot during your first run. One thing I will do, I will set the target counter to 3 so that we have the maximum size or the maximum weight of our conveyor belt in, and then we can press start to program or produce our 3 parts. So now he's asking me about the pallets. So we have a pallet operation, a pallet system, which asks you when you change a new job, if you change the raw material pallet. And so he asked me if the conveyor belt was emptied already, so I can say okay. And now we can press start to run the program. So now he's searching for the first part in slow-mo. Take the first part out of the stack, bring it to the alignment station, align the part, reorientate the gripper, bring it to the bending machine, push it against the back edges, reorientate the robot, regrip the part, reorientate for the second bend, again searching for the back edges, put the part on, and then we are put it down to the conveyor belt. First part was done. Now he's go much faster to the stack because he knows the correct height of this stack, and again do the same operations. So last part of this stack. After he done these 3 parts, the conveyor belt will automatically feed out the parts until the station is emptied again, so that we make sure we can lay up the next parts easily and quick to the conveyor belt. Maybe as you remember about, you see the part a couple of minutes before when I'm cutting, and also you see the parts immediately before by programming from my colleague Garrett from Switzerland. Okay, so now job is done. Conveyor belts will feed out now to that position that we can remove the whole parts and bring out the new ones. And from this side, I'm at the end. I say thank you for the time. Hope you enjoyed the following positions, and hope to see you soon again. Thank you for this.
Thank you, Eric, for presenting the mobile bending cell with the Expert 80 and the conveyor belt. I shortly want to switch to our Slido vote, where we asked you what is the most important purchasing criteria for bending automation. And the final vote shows exactly that speed and performance is the most important purchasing criteria for you, and also the constant part quality is a big point for you when you think about bending automation. And if we think about a manual bending process on a press brake, what is the most speed killer and time consuming action you have to do in a bending process on a standalone? Yeah, we have to say sorry for this short interruption. We had technical problems. You can see it's a live event, and yeah, not everything is going right all the time, but we fixed the technical problems, and so we are back live here from our technology center here in Germany. And I will step in where I lost you or you lost me from the stream. So we talked about our mobile bending cell and your votes regarding the purchasing criteria for bending automation products. And yeah, as I said, speed and performance is the key for you, and also the constant part quality. And it's the same for standalone press brakes. The most time-consuming part, if you do bending jobs on a standalone press brake, is the tool changing process. And to be also here very fast and directly address this point to have high performance in the process, we also offer a good tool changing solution on our Expert Pro series. It's the modular tool changer. And we want to show you in the following the modular tool changer, which is the tool changing solution for our Expert Pro series, available for the whole range of the Expert Pro series, and our latest product in our bending automation portfolio. I will hand over at this point to Ronnie, who will show you the machine in detail.
Thank you, Benedict. Welcome from my side. My name is Ronnie, and I will explain the modular tool changer. Why we call the machine modular tool changer? Of course, we have the normal Expert Pro, and the module, the additional one, is the robot behind. We will see later on if we change the tools. The machine is a standard Expert Pro edition. You still know the machine. You have seen it before. Stefan explained a little bit about the machine. I will explain how we can handle the tools with the robot. You can see on my screen, this looks a little bit different. Of course, we have to know what kind of tools we will handle with the robot, and of course we need the information what kind of tools we have still in our machine. If we go to the machine, we have a look on all the tools inside. You see quite different setup of tools. We have long tools. This is 350 millimeter long. We have a normal tool like 250 millimeter long, and also different segment lengths, like 100 millimeter. This is the longest one we can handle with the robot. This is 550 millimeters in the length. Then we can also handle horn punches we have here. And a little bit the special situation we have here on the right side, we have a ghost neck tool, and in the last segment is also a rotated tool. This means we can also rotate with the robot the tool if it's necessary. You have the situation like this, or you need the position of the tools like this. If you change the tools, you will also see what do the robot inside. We store the tools every time in the same situation or the same direction. This means you don't need the double of the space. You need just one space for one tools, and we can just in case rotate the tools. Okay, how we can change the tools? During the changing, I can a little bit more explain about the different tool sizes and types we can handle. Of course, I can select what should do the robot. In our case, we will change the tools. Let me say, maybe Eric is cutting some of the parts in one presentation before on the laser, and we will bend this part. We go to the area we can handle the machine, say we will load new tools, and he was kindly to send the tool and also a paper with some codes. I can just scan this, say no, the last part I don't like to save, and we are still open the right part. It's very easy and very simple. I cannot do some mistakes. Normally, I go to this tool setup plan, and the operator places the tools on the right position. You have also seen we have the optical bend guide system. The operator will be guided on what for place you have to put in the tool. In our situation, we will do it with the robot. Now you see a little bit a different view. The top is the new tool setup plan, and the bottom is the situation we have still on the robot. We select fast change for the upper tool and the bottom tool. Press just the start button, and now the robot get the information what he have to do. They are going to the start position, waiting that everything is ready, nobody is inside or something like this, and then they are starting. On the first tool we are changing, you see a little bit a special move, I will say this like this. You see like this, the tool is really long, and on the outside then the robot move a little bit different. They are placing this to his place in the stock and go to the next one. During this I explained a little bit also for the bottom tools. You see a very small one, this is in V6. Then we have also a tool, this is 100 millimeter high. You can handle different heights of the tools, and a really big tool. This one is a V120. We can also handle with the robot. This means we can handle from V6S, this is a small edition, also to up to V120. Now we have an interesting point. You see the first tool of the last station is still remove, but this is rotated. And you can maybe see, if we have the camera inside, that the robot move the tool first of all on a special position. They are rotating the tool, or the robot rotate the gripping position and put this away in the stock. This goes automatically. I don't need to program something. This is very easy and very simple. Then you see we go to the bottom tool, and if you look on the machine, then maybe you ask why the robot don't remove the top tool. And you will see that we go to the big tool now and don't remove this one. Of course, the software looks, what is my next job? And if it's possible to take the same tools I had before in the machine, then we will do it. A normal operator will do it the same way. They are looking, what is my next job? Look what tools are in the machine, and then he say, okay, I don't replace all the tools and put the same tool in. The tools I can use are still on the machine, and we can add just the tools we are need for our next job. Like on the bottom tool, you will see it. We can do this on the right side. The station could be also on the right side. We can add this on the left side. We call this smart segmentation, that the robot find the right solution for you or for the operator, how he have to segment the tools. There's also a different thing. There's calling smart routing. This means that the robot defined what is the best way to move from one point to the other point between the stock or between the clamping and the stock of the tools, that we can also save a little bit time. In this time, the robot is moving the tools. Of course, they can prepare the part. I still prepare the part on the bending aid. You can also see the bending aid in this part. And then I can prepare all my papers and so on. And if the robot is finished, then I can start to bend the part. How I say before, this part comes from the laser. I have the part the first time here. I will go to the bending part, switch to the produce area. Now I see how I have to handle the part. I explained before, I use the bending aid, and in this case, of course, I use also the lamp system that we get the right angle. So let me move this on the right position, touch the part on the right point. You have also seen that the safety system is moving down to the programmed high of the tools, and that we look here around, that I don't stick the fingers inside and have an accident. This goes automatically, and then we can start. So you make the first bend. You see the bending aid is also moving with the part. Bend is finished, and then I replace it. The next bend is on the left side, I think. Then I move the part, of course, on the right position. So here I use the snap function. Stefan explained this in the presentation before, that I, on the right position on the left side, the next bend should be on the other side the same. We do the same bend. And then we are rotating the part, moving to the other side. And put the part like this. So then we are finished, and we have the finished part still. Very easy and very simple. Let me put this away. Then I can show a little bit more how we can handle the tools. Of course, if I like to bend on the machine and will place the parts or the tools manually, I can also press just remove the tools. Then the robot will remove the tools. Of course, everything is moving to the parking position. I don't need the bending aid. I will move this away, and then you see this goes very fast. Of course, everything should be on the safe position, and then the robot starts automatically. Now I will switch to the second page. We see a little bit the situation in the stock. We have 3 areas. We store the tools. We have the left one. We have this in the middle. This is on the door behind and also on the right one. And you can see the blue area, or the blue tools are all the tools inside the stock, and the light blue one are the tools I have still here on the machine. They are replacing now to the stock. What you can also do, you can also work with the machine together. This means if you have not all tools inside the stock, you can also say, okay, the robot move all the tools you have in and make in additional the missing tool segments per hand or manually. This is also possible. The software say, okay, I can also handle maybe 2 segments, and the last one you have to do manually. You can also operate fully manual on the machine, like my colleague has shown in the beginning to present the machine, that they are moving the tools manually in and out. Very interesting point is, if you say you need a different setup tools in the machine, maybe you bend in the next weeks different parts or something like this, or you like to change a little bit the stock inside the machine, then you don't need a technician or special skills to do this. I have just 2 segments just to show how it works. You know, I can open the clamping and can move the tools manually in. And in our case, I don't like to use the tools to bend. I will teach the robot I have new tools, and please take the tools and store it in the store or in the tool magazine. So how it works is very simple. I say just load new tools. You see I have 2 different areas or 2 different ways to go. I will change upper tools. I have to check what kind of tools is it. I select the right one. This is in P5. This one, 250. And the bottom tool, I can double check. This is the V12. This is only the information I need to give to the robot. This is like this, you see. And a simple press on the start button, start the robot. But the robot do not remove the tool. Of course, they are not knowing about the position. They are moving now over the bending area, not the complete bending length, but in the area from 500 to 2,500 millimeter. We have a little laser on the gripper or on the robot, and they are scanning the whole length for all the segments. The good thing is you can do it how I do it for the top tool and the bottom tool, and you can also place a lot of segments that you can save a little bit time. You don't need to do this just for one segment. Of course you can. I do it just for the show how it works, but you can also place 10 segments on the machine and say, okay, now please scan the position and move it in the tool magazine. If you are finished on the top position, of course the robot goes down for the bottom tool and doing the same. We can see the position for the top tool. P5 I selected, of course, this is just for double check. The exact position I put this in the machine. And the length, they are measuring 99 millimeters and define for me, this could be 100 millimeter segment. Of course, I could change it. Normally, the robot defined the right one. If we are finishing then the robot goes to the parking position and wait what I decide. Of course, I can say, okay, I will just scan the tools and maybe I don't like to put it away. In our case, we will say, okay, put it away in the tool magazine. I just press the adapt button and then the robot search an empty space in our magazine and store it on a free area, what is the best area for the tool, that we use the space in the best and economic way. First, the top tool, you see, this will be going to the left side of the machine, and the bottom tool, we can also look, we have a space on the left side. The top tool was on the right side, sorry. So then we are finished. Tools are stored, and then the robot is also finished, and I'm finished also with my presentation, and I will go or give to the colleagues, to Benedikt and to Carsten.
Okay, thank you, Ronnie. We have the next Slido question for you already online, and we would like to know what is the main reasons for you to go for a tool changer. Today in the morning there was, for example, also a question about tool cabinets. How do you see the tools which are in? And that's something Ronnie has just shown you as well. You see all the tools in the screen, but you have these tools also in your BySoft 7, for example, as a tool cabinet. And you can have this for different machines, of course, also so that you have all the tools which are belonging to every machine in different tool cabinets. And you have, for example, also a tool cabinet for the big automation. We will come to this in a second. And you can use this kind of stuff in BySoft 7 or also on your machine to make the difference for yourself. So you can say, okay, I would like to activate just when you look for bending sequence or for the right tools to bend the part, that you just use the tools which are in your tool cabinet, or you say, okay, I would like to look for all possible tools, and then you can purchasing one additional tool if you need to have this tool afterwards. That's all open for you. So what we have here now with the questions about Slido, setup time saving is one of the most important points. Of course, you can save a lot of setup time. You can do something different in the time when the tool changer is doing the tool setups. We have a number of additional new features on this, and Benedikt will come to this in a second. Protection of employees is an important point for many people nowadays, because they have customers, they have operators on the machine, and these operators, they don't want to carry these heavy tools anymore. You don't find any people anymore who want to lift heavy tools anymore. And so you protect your operators with this. Now, increase of the lifetime, it's also interesting, now, of course, because the tool changer is just putting this tool in, which is the right tool for the job. You don't have ever any mistakes in this system. By the way, we have an optical tool detection system also available on, for example, the Expert 40 and Expert 80. That's a camera-based system. Eric was explaining this before. And this system is also looking from the backside and checking if you have the right tools in. So it's also for safety of tools and safety of the operator. Small batch sizes, at the end of the time it goes, or at the end of the day it goes the same direction like setup time saving. If you have very small batch sizes, you need to have a small fast tool change, because that's the process which is most time consuming. We have speaking before about the different speed options of the machines, classic, performance and dynamic edition, and this gives you much more speed, but still the tool changing process is the process where you can save most of the time, and for this we have the tool changer and tool setup optimizer. Yeah, and increased quality of the part, of course. When you have the right tooling in, you get the right part quality out, and that's one major point as well. But I think interesting is also the new features which are on the tools changer, the software features, and I think them are you can explain them best, Benedict.
Exactly. So what we want to address with our modular tool changer is exactly the pain you want to solve with setup time saving with a tool changer. And we did this with an intelligent software. One part of the software was also addressed from Ronnie in the presentation. So to have a smart segmentation, so tools which are already into the clamping, you can add or remove for shorter or longer bending length of the same type of application. And what we additionally did with software improvements is the smart routing function. Smart routing, what does this mean? It means that we have an intelligent tool changing process. So the software realizes what tools are needed for the next bending job, what tools are already into the clamping. And we directly keep the tools which are in the clamping. We move them, for example, also away, park them, and remove them, so we do not have to bring them from the tool magazine again. We also bring tools away and directly move new tools into the clamping, so have an intelligence behind the tool changing process. And we made tests, and we can save up to 30% cycle time from one job to the other with this new software function. And I think it's a good step forward with our new modular tool changer to directly address the vote you also voted for setup time saving with our modular tool changer.
Yeah, with this, and before we coming close to the end of our show, of our event of today, this will be the automation, the big automation. We come to one more question. What is the most important topic for automatic tool changing? Is it the tool setup time or tool setup flexibility, the tool change cycle time, or the tool capacity? That's also interesting. Now we speak daily with different customers about their opinion. What is the most important? What's the most important for them? Some customers say, for example, tool capacity. Now the second generation of the tool changer can carry up to 54 meters of tools when you have a 4-meter machine. And so you have a big capacity for your tools. Then you have the tool changing cycle time. That's something we addressed before. We have seen that this is an interesting topic. And then the flexibility, we speak about what tools can you handle. Now with the tool changer here, with the MTC, you can handle, for example, lower tools up to V120, so huge lower tools for bending really thick parts you can handle with this. And that's really, if you have an operator and he has to handle these tools, that's not so funny. It's the same for the upper tools. The biggest upper tool, what is it at the moment, what we can handle from the height of the upper tools?
The height is 350 millimeter, and from the length we can handle tools up to 515 millimeter, and this goes directly in the same direction you mentioned before. It's then especially worth for the operators for the big tools and the heavy tools in the tool changing process. And if I could add something, this is exactly why we decided for a robot for the tool changing process to directly address the flexibility in the tool setup, because with the robot we are flexible. We can remove and add tools at every position into the clamping. We do not move tools in from the side, so to keep up the flexibility in the tool setup process.
And the flexibility in the size of the tools. You can have even this visibility process, it's called in our company in Bystronic, you can have even different tools, and you can ask our sales managers worldwide for this if you have there more questions. So you see tool changing cycle time, but it's the most important topic for you. And we have here a nice solution for this with our tool changer. If you want to see this on your own parts, no problem. Just book a demonstration for you individually. You can send your parts to us. We will make everything ready for you, and we can do this together. You don't need to give the parts before the demonstration. You can give us the parts also in the demonstration. We do a live demonstration of the software by Soft 7, how we make this ready for cutting and for bending. All this we have done already in demonstrations, or we do daily, and you are really welcome to give us your parts you would like to bend and you would like to see with the tool changing process, and maybe you would like to see how fast the tool setup time is in reality with our solution. Now with this, we come to the next point in our agenda. We come to the next and last software point, and we give hand over to Benjamin again to present this last software point.
Welcome to the presentation of the BiSoft 7 module Plant Manager. My name is Benjamin, and today I will show you that the Plant Manager is a unique tool with which you can plan and monitor all laser cutting and bending processes in both an automatic and informed way. Every ERP system is divided into individual work cycles along the production chain. One of these cycles is the general planning of the cutting and bending processes. This is where the Plant Manager comes in and automatically refines this planning. In this way, individual steps and time are saved, costs are reduced, and error sources are eliminated. In addition, the Plant Manager initiates and monitors production and provides you with comprehensive statistical data. The starting point is the creation of a production order in the ERP system. The order number as well as parts lists work processes and production date are specified here. This order can be transferred directly to BiSoft 7 Plant Manager via an XML interface. It is therefore no longer necessary to print out the order papers. Repeated parts are recognized automatically, and any revision statuses are taken into account. New parts can be imported and programmed automatically via the interface. Cutting and bending technology are also set automatically. The status of an order, including its operation, is possible at glance. Open as well as incomplete and overdue orders can thus be displayed at a glance. The scheduler automatically nests the laser parts and creates complete bending jobs. It plans the jobs according to the end date, to the machine technology, the subsequent work steps, and optimal setup processes. The Plant Manager groups parts according to the material type, the material thickness, and date, as well as according to the cutting head, the cutting nozzle, and the machine. He creates optimal cutting and bending programs and uses the appropriate technology. Plant Manager reduces setup times through optimal planning of the bending tools. Select the bending parts and the right machine, and create the optimized sequence. The Plant Manager communicates constantly with your ERP system and provides it with all the necessary information. Material reservation and order status can be transmitted. The jobs that have now been created are planned in the calendar and sent to the machines on time. The operator can start production without further intervention. After the cutting and bending process, all production data is reported back to the ERP system for post-calculating. Material consumption, including waste as well as effective processing time, are determined here. The operator, the machine operator, is supported with the part removal module, which is installed in the clearing area of the machine. The cutted plans are displayed here, and the operator receives visual support in order to clear the cutting plan from the shuttle table, quickly and according to certain criteria, such as an order number. Rejected parts can be reported back and be reproduced here. Besides this, is also possible for batch management and residual sheet management. We will now switch to the machine and watch how an operator works with it. This is how quickly and easily you can create perfect Plant Manager jobs with BySoft 7.
Yes, thank you, Benjamin, for the presentation of the Plant Manager. I think it's a good idea to directly go to our vote system. After we had the request before and the remarks regarding the Plant Manager, we opened this vote for typing in some information. Because, as we said, we are happy to have your feedback directly regarding our products. So the question was, what are most important functions that are missing in the Plant Manager? And here we have a perfect remark from your side, what is missing in the Plant Manager. So as a product manager for bending automation, cannot go too much into detail regarding your remark. But also our colleagues, PM colleagues from the software department, Vladimir and also Kansu, who are responsible for our software products and also for the Plant Manager, will receive this feedback from your side to hopefully improve in the future regarding this topic and this remark. So thanks a lot also for this feedback regarding the Plant Manager. I can promise to you that we directly forward this feedback to our colleagues from the software department to solve these issues which are missing in the Blend Manager into the future. At this point, I want to add another question because we talked a lot about the automation processes for bending. And especially here, I want to know, or we want to know, if it's important for you to see alerts and also job updates on your mobile device. So when we talk about the mobile bending cell, as we did before, and in a few seconds we will talk about the bending cell. It's an automatic system. No operator is taking care about the system because it's run in an automated way. And for this reason, also an important feedback for our colleagues, our product management colleagues from the software department, if it's a big need when you run an automation system to have alerts and also job updates on your mobile device. And we received already 6 votes, and you say clearly yes. It is a topic, and I want to have these alerts and also job updates on my mobile device to really have an overview about my machine, about the process and the jobs which are going on, to be always informed. So I think, it's a good feedback also for us because we have our ByCockpit, for example, as a software which directly delivers this to you. But when we see how important this is to you, we also will address this to our colleagues from the software department to set the focus also on a device like the ByCockpit, which takes care about the whole automated process with job status and also alerts to this. At this point, I want to overhand to my colleague Stefan. He will present you our last topic of today, but it's last but not least, I can say he will show you our bending cell, our biggest bending automation product, and we show you this also directly live here in a demonstration. And I'm happy now to overhand to Stefan, who will show you the whole system in general, what we can do at the moment in our bending automation portfolio. So let's start with Stefan.
Hi. So let's have a walk through our bending cell. Here we do have 2 pickup stations where we can set up the parts. Here we have pallets with a hole pattern where we can use some pins to align the parts in one of the corners of these pallets. That makes it much easier for the operator to set up the pallet. The same system you have seen on the small, on the mobile robot. There we also have the pallet with these hole pattern, also with the pins. Here is the very same. We also do have separator magnets, which separate all magnetic material parts to lift it a little bit off in order to have them not stick together. Here we do have our reference station. We also do double sheet detection. Here it is movable. It's about 800 millimeters range, in case you have cutouts here in the corner whatsoever. Let's have a walk around. Here in the front of the press brake, we do have 6 pallets for set down the parts. All the bent parts that the robot has done can be laid here, so the operator can easily remove them through the doors. What we also can do is we can pick up the parts from here. It's not only set down pallets, also pick up pallets. But in this case, it's just flat pallets without the hole pattern. In the back, you can see 5 gripper trays. There we can store our different gripper types. We can see 2 with vacuum, 1 with magnets, and we can see 1 with what the robot is using to change the tools. 1 is empty because that is the space or the slot for the gripper attached to the robot in a moment. On the left side of the bending cell, we do have our tool rack, just the same similar system to the mobile tool changer. Here we have it in a linear rack instead of a splitted rack. and we have enough space for all the tools that you probably or maybe need in your bending cell. Here we do have regrip station. This regrip station is pre-programmed in the robot manager. It is fully automatic, moving to the programmed points, so it's not a manual adjustment. We do have 4 suction cups, 2 in the bottom, 2 in the top. We have 3 clamps, 1 in the bottom, 2 in the top, which we're also going to see later. Furthermore, we do have the tool orientation change station, let's call it like that. So in case we use the tools reversed, especially the punches, the upper tools, then the robot is dropping the tool in here, reorientate and pick them up from the other side to insert them into the machine. The machine is a 150-ton, 3-meter press brake, or 3.1 meter press brake. It's dynamic edition, so it's the quickest, just as we have seen on the mobile tool changer. Also, it comes standard with the grounding system, it comes with the side frame compensation, it comes with all automatic compensation system, plus we also have the laser angle measurement system, which can be used together with the robot. The robot is, in our case now, a 90-kilo 6-axis. It's mounted onto the 7-axis. It's the linear track to move the robot through the cell. So I will go outside to start a program. Just as on the small one, we have to close the doors. We're going to lock the doors. And we start the program. So the magnet gripper is now moving in front of the pickup station. It's now searching for the first part. What we can hear is a vacuum nozzle with which we detect if the part is attached to the gripper. It's a magnet gripper. This one is a super strong one. It could possibly load up to 350 kilos. The part, of course, is a little less. 90-kilo robot basically means that the part can weigh 45 to 50 kilos. It is because of the center of gravity is moved away from the robot point, from the robot head, and therefore we have a little less capacity or a little less load of the parts itself. So we bend the first part, the first angle. Also here we do have contact fingers, so the robot is pushing the part against the back edge in order to have the correct lances or bending length results. Now we're going to use the regrip station with the vacuum cups to reorientate the gripper. And we continue with bending. So this part is bent. We lay it down on the sit-down pallet. Now the robot is changing, because that job is done, the robot is changing its gripper head. Therefore, it moves this gripper. First of all, of course, it loads the new program onto the robot. Then the robot is bringing the current gripper in the gripper tray number 3. Well, it should do it. Da passt er aber nicht hin. Let me do it a little differently. 1 second. So we do have the very same programming software or operational software as on the small press brake, but here we do have, of course, the tool change and the gripper change as well. So I'm starting the tool change right now. Okay, I probably do have made a mistake while I programmed the program. Re-enable, edit. That was too quick. This, to change, start. Okay, for some reason, he tries to lay this one down into gripper train number 5, which is the wrong one, cannot reach this one. So, 3, this one we move to number 2. So, the robot is checking if the tray is empty, where to place the gripper. This one's okay, this one's okay, this one's okay. Edit. Okay, start. Okay. So it's now removing the gripper, it's placing it into tray number 3. It then is picking up the tool change gripper and start to change the tools. In the meantime, I will shortly interrupt the robot while doing its job, and I start the tool change manually because I want to make sure that the gripper change afterwards is working perfectly without interruption. So it's now waiting for the tool clamping to be open. It's about 10-second time delay. When the tool clamping is open, the robot starts to remove the tools. Okay, in the meantime, I fixed this one here. Okay, so the robot is now removing the tools in order to make space, of course, for the new ones. We have seen it similarly on the mobile tool changer. Here is the very same. Big benefits of this is while the robot runs overnight or during day shifts, weekend, whatsoever, it can automatically change to other jobs as well. That means in case you have multiple jobs which have to run through the robot system, this robot is changing the gripper, this robot is changing the tools, and therefore this robot is changing the products that going to be bent on it. Most of the systems on the market are good to run only one product with the robot. So in case you change the program, some human has to interact, have to change the gripper by hand, have to change the tools by hand, have to set up everything by hand. Here, everything is done by the robot. So you start the job in the afternoon, you come back in the morning or maybe over the weekend, and all parts are bent, not just one type of parts. That's a very big helper. That's very, very helpful. Okay, last tool to be removed. And then we start to load the new tools. In case you're not sure that this system is the best what you need, maybe you are not sure what tools you need, maybe you are not sure what machine size you need, maybe you are not sure what robot you need, we are happy to help. You can send us, or your salesman, your contact person from Bystonic, you can send him your programs that you wish to run on the cell. Then we can check what robot size do you need, what press brake tools do you need, what gripper tool do you need, and ultimately what press brake you need. We have a quite range of Expert Pro machines that you can run in this bending cell. We start from 150 ton, 3.1 meter, as you can see here, and we go up to 320 tons, 4.3 meter, with the same layout. Robots can be chosen from 90 kilos, 150 kilos up to 270 kilos. That is the capacity of the robot. Roughly half of this capacity is the maximum weight of the part itself. This is, as I mentioned before, due to the moved center of gravity away from the head of the robot, so away from the direct contact point on the robot. Of course, when we move that, the force getting bigger, even the same weight is loaded. So you can easily do 135 kilos, maybe up to 150 kilos on heavy parts on the biggest robot that we have on offer. Now he's loading the left tool station with the punches rotated or not rotated, so in a standard way. These punches are a little crooked, so they're not symmetric, they're a little off to the front. They have a cutout on the backside. The punches on the second station, on the small station, they are rotated. Therefore, we can see how the robot will handle. The robot can load small punches or punches from the shortest length of 30 millimeters up to 515 millimeter long punches. As you can see right now, this is a long one. For the bottom tools, it's from 50 millimeters up to 515 millimeters. The tool load is up to 25 kilograms. That means you can have really big, really heavy tools, what the robot can handle. Now we beautifully can see the reorientation of the punches. Therefore, it set the tool onto the regrip station in the certified slot for that, and drops the tool there and picks it up from the other side. He's doing this with the other last two. Here we have a range of tool lances that we use. We have multiple different lances. We go from 55, 70, 60 is there, 275 up to 515 millimeters. This allows us to have the tools exactly for the correct bending length that we were going to bend. So it's always recommended, especially when you have automation, to have long punches and also a segmentation, so you're absolute flexible when it comes to bending lengths of your parts. So that was the last one. Now the robot parks there. I'm starting the bend program now. So therefore the robot is placing its tool change gripper in rack number 1. This is always classified for the tool change gripper, so it's blocked for this one. So there can not be any other tool for the gripper, for the robot. So we now pick up the suction gripper with 4 suction cups. This is a special design. It's a custom design. Made for the parts that we're going to see. The parts are a little too big to use a straight gripper, so it would always collide with the arm of the robot itself. So here we made a special design. As I said, whatever custom gripper you may need, we are happy to design it and to help building it. Now we search the first part, just as we have seen on the small press brake, and also that we have seen in the first part that we bent. Then we go to the regrip station, to the reference station, double sheet detection, and we do the first part, first bend. Here we use the following function. In this case, we have to follow up because that's the way the part is moving. We have a very small flange that we bend, and in order to continue with the program we have to regrip. Here we use the clamps. We have seen on the other part we use the suction cups. On this part this is not possible due to a lot of holes in the contours of the part. Therefore we can use the clamps. Then of course continuing with the bending. And here also it's very handy that the regrip station is moving automatically, so no one has to set them up. So now we do a regrip while the part is held by the press brake. The robot is not moving away from the part. I programmed it this way so the part is not hanging downwards, and therefore it's not denting. So the robot also can change the orientation of the gripper at the part. Now you saw the following up. On this bend following bend, we are not supporting the bend part by the robot because on this point the part is stiff enough, so we basically do not need this following function of the robot. So, this is the last bend. Then it takes the part and moves it to the set down pallet. It goes to its parking position or its center or home position. Basically, it's the home position, and pick up the next part. Now you see, it's not searching all the way for the part because it remembers from the previous part where it was. And so the program will run through all the night. Now the regrip with the clamps again. Reorientate the gripper to all the other side. Pick up the part and continue with the bending. Now, beautifully to see the following up. And after this bend, also the repositioning of the gripper on the part while the part is held by the press brake to not lose its position. And then we continue with the other side of the part. Now we also do, or we do again, a repositioning of the gripper. We rotated the gripper 180 degrees, so we can rotate the part and continue on the other side of the part. And also here you can see the part is, we bend the part off center of the press brake, so we are not in the center. Here our crowning system kicks in at its best to have the part all align over the whole bending length. That means, as most of you already answered correctly in the quiz, that the whole angle is correct because of the crowning system. So it's constant on all the part. So that's from my side. I hand back to Carsten and Benedikt.
So, thank you, Stefan. And this is a live event, and there are also technical issues. And some of you even follow our Chancellor, Angela Merkel. And when you read this, what she says, for the German people, internet is still something really new. And you can see this also a little bit in the technical issues we have had today. But we really try our best and to come up with solutions. What you see also outside now, it's getting dark, it's getting late, and we are nearly at the end of our event, and we have the next poll already set up. And we've got a first feedback that you look for the future for automation and bending automation. And that's also what we think, what we see also coming in. We have a lot of projects we are working at the moment on. And that's especially in times like now when you have a corona, for example, and then you can't go into your factory, then maybe you are happy if you have automation there which can still operate some parts for you. Or that maybe less people can go into the factory. Because today here also have been not so many people, and we could do all this event with minimum people and highest safety for everybody. So we see here, maybe soon you will invest. Let's come to the next and final question about technical questions. What is the most common unsolved problem for bending cells, in your opinion? Now we have seen today, we have seen in a live event technical issues, but it's maybe also because it's now late and we started very early in the morning and it's getting dark again. The same as we have been starting in the morning. But let's see what's your feedback about this. Is it the programming time? What's the most important point? But programming, maybe Benedikt will say something in a second about this again. The layout flexibility, also Benedikt, I think, can say something about this in a second, what we do with our solutions. Loading and unloading of the bending cell. Process reliability and part accuracy. Maybe there are some other points which could be a reason for you. But Benedikt, what do you say?
Yeah, thanks for the introduction. Yeah, exactly. To the point of the layout flexibility, we have seen these requests in the market. At your side, we talked to a lot of customers, and we will improve our bending cell based on the system you have seen here in the demonstration directly into this direction. So to be more flexible regarding the track length, be more flexible regarding the placement and pickup stations, be more flexible where you place your components into the bending cell, and also be more flexible in the layout itself for the bending cell to really address this. Because we see a bending cell costs a lot of space, and space is money, and for this reason every factory is different at customer side, and we realize this, and we will have a bending cell with much more options regarding the flexibility in the future as a standard. But what we also do today is that we have our customization process. So if you have a request regarding a bending cell, and you have some space issues, or you need more space into your cell for bend parts and pickup of parts, it's not a big deal for us. We have a customization process. We can do this for you. So we take up your requirements, and we build the cell regarding these requirements from your side. So at the moment we do it with a customization process. In the future it will be then standardized. All the requirements we get today will be a standard in the future to have exactly the mentioned point you mentioned here in the poll, that layout flexibility is really a pain point. And also the second point regarding the programming we address, you have seen the Robot Manager programming for the mobile bending cell. This is absolutely new and unique and easy. And this Robot Manager programming will also come for our big bending cell as the leading programming software, so that we also get the ease of use or the easiness of the programming also for our big cell. Exactly. These are some points regarding the flexibility and also the programming software to give you here a feedback to your votes. Exactly, yeah.
Okay, and with this we come to the last question. And that's a question, if you should do something like this again. We are really looking forward for your feedback for this. If this was interesting for you, you can give us your feedback also in the chat, or you can type in this also here in the chat of Slido. It's really interesting for us, and we have seen this today in the morning already, similar, that there is interest for this, and yeah, we are working also on this. We will see the next events already at the end of January, beginning of February. Yeah, they are scheduled, and hopefully already with a new laser then, with the new 15 kilowatt laser here in our showroom and with the new equipment. Because after this show, now tomorrow is one more day of show, and after this we ship everything out, and we get all new equipment in. That's then the change of the year. I would like to say thank you for the complete team, for everybody who was supporting us, and also for Garrett, who was supporting us really much again in the chat, and also who was doing the presentation of the software of Robot Manager, and Benjamin was doing the presentation of the software of BiSoft 7. Thank you for all of them, and Benedict, your last words?
Yeah, also thank you from my side. It's a nice possibility to do this in a digital way to present ourselves. But as you have seen in the last 3 hours, it's also a good way to come in contact with you, to get directly your feedback, and maybe also directly answer some questions you have to us. I think this is the way how we want to handle it also in the future. And yeah, we are happy that the feedback is positive like that. Yeah, that's all from my side. Also, thanks to the whole team who made this possible.
Thank you. Bye-bye.
Bye. Thank you.
Bystronic is a leading global supplier of system solutions for the sheet metal industry. We provide laser cutting systems, bending systems, automation, software solutions, and comprehensive services.
Sorry, I need a sip. Ah.
He's good, no?
Mommy, mommy,
Let's say he has a confident voice, yes.
Shall we? Client happy?
Client happy, but please get to the end of the line this time and add a little verve.
The verve is there. You may not be able to hear it right now, but you will in post-production.
In post? We are in...
We offer worldwide presence and competence. We speak your language and understand your needs. We are here for you.
Sorry, we are here for you. I mean, I hear the words, but I'm not getting anything from them, you know?
Could you please just say the lines?
May I?
Please.
It means that we offer much more than just a machine. We support our customers with flexible financing models, training, maintenance, a long-term spare parts service, phone hotlines and online support. And we also operate local sales and support offices in many, many countries.
Yes. Now you see, now it's
coming alive. We should be saying this.
It is more text, though, so we will have to renegotiate with my agent.
Can't you just record it and we'll look at it later?
Well, I'd love to, but my agent would kill me.
If only. Fine then, continue with the script.
Right you are. Where were we?
At customer service and post-sales services, would you believe?
Rolling.
We don't simply develop machines that cut or bend sheet metal. No, our customers need flexible systems for ever-changing order positions and batch sizes. Automation to achieve top productivity with integrated systems and the right software that cross-links everything. Bystronic stands for Swiss quality.
Sorry.
Really?
Swiss quality. I mean, it's a bit of a cliche, isn't it? And actually, while we're at it, your slogan, best choice, kind of sounds like we've just won the buzzword bingo.
Guys, if you want to sort this out, I'm just going to pop out for a smoke. Let me explain. First of all, Swiss quality. Do you know the Bi-Star fibre? Bi-Trans Cross or Bi-Soft? Have you ever seen them laser cutting and bending those sheets? It's like butter. Once you've seen it, you can't help but be excited. The beauty of a laser cut. The precision of a bent metal sheet, from very small to very large, but all with the precision of Swiss clockwork, perfectly formed and expertly fitted. Now, best choice. When you say yes to a partner, be it in business or private life, you make a commitment to the future. Bless you, Katie. Now, you're still young, but one day, you're going to want someone for the long run. Someone who shares your vision for the future. You see, at Bystronic, we think about tomorrow's sheet metal processing. We have some footage of that, right? In what we call the Smart Factory, variable orders will be produced automatically on flexible systems. A clear vision and state-of-the-art technology means cost and process optimization, which in turn means higher earnings. And who's behind this success? The employees of Bystronic worldwide. Now, you'll say that's just another cliche, but nobody else sets new standards like they do. With their enthusiasm, their ideas, and their know-how. Actually, I stand corrected, because our success is also due to our clients. It's their feedback that we use to develop new technologies. And until they are perfectly functioning, we will not launch them. And none of our employees will settle for less. Not in Asia, not in America, not in Europe, not in Switzerland, nowhere. And that's what we mean by best choice. I'm sorry, I think I interrupted you.
Did you record this?
Sorry, did he say something? I couldn't hear a word.
He says we're done.
Really? That looked like more words to me.
No, really, we're done. But you can stay here till 5, because it's in your contract.
Oh, no, I'm more than happy to do another version. We'll just speak to my agent later on. That's no problem. Gentlemen? Hello?